Every website has a different theme. Most of them also have different fonts. So if you try to compare this font right here of the heading, you'll notice that it's a bit different from the one that we have right now. The current font we're using is specified in our layout.tsx. It's the Geist Sans local font, but that's not the one we want to use. So we want to use a font family that's specified in the Figma file. And this one right here is the Inter font. I think we can see it right here under typography. So head over to Google Fonts and search for Inter. Click Get Font and then download. Once you unzip it, drag and drop this one right here under Fonts. It is the one that ends in wght.ttf. And we can rename it to something more meaningful. So let's go ahead and do that. I'll call it intervf.ttf. We can also delete the two fonts right now in the fonts folder, and we can put Inter to use. So we can use it right here by renaming this one to Inter, use the local font, and then simply pass a source to the /fonts/intervf.ttf. We can give it a variable of --font-inter, and we can use all weights, 100, 200, 300, 4, 5, 6, 7, and 8. We can delete the second Geist font. We can also delete the Geist mono. We can go down, and instead of using these two variables, we can now use the new one, which is going to be inter.variable. We also need to modify our tailwind.config.ts. Right below the screens, we can say font family, say Inter, and specify it as var --font-inter. Now we can use it within our app. So I'll keep the current one, but I will wrap everything in an empty React fragment, just so we can show two elements, one after another. There we go. We have the initial h1 right here, and right below it, I'll duplicate it, and I'll change the class name to h1 bold, but I'll give it font Inter. And I'll say welcome to the world of Next.js and put Inter right here in parentheses. Now, if you check them out, they both seem to be the same, right? So why is that? Well, we can only keep one, right? Because they're the same. So if you head over to globals.css, you can see that we're already specifying that all fonts within our body have to have the font Inter. So we're good. We don't have to mention it using a variable. But I want to quickly talk about this local font functionality coming from Next Font Local. It is pretty cool because it allows you to eliminate external requests to font providers like Google Font or Next.js Font, and significantly improves site loading times and performance. Think of it as self-hosting your own fonts right here within your code. Now, if you go back to Figma and scout some of these components, you can notice that for our logo, we're using a different font, Space Grotesque. Do you think you'll be able to install it and use it on your own right now? Pause this video and go through the process alone. Do it right now. But anyway, whether you succeed or fail, I'll lead you through the process of installing another font one more time so that you truly know how to install all the fonts. I'll head over to Google Fonts, search for Space Grotesque, click Get Font, and I think we already got Inter, so I'll just get Space Grotesque. Download it, I'll unzip it and drag it into Fonts, rename it to Space Grotesque vf.ttf, go to the layout, duplicate the Inter font, call this one Space Grotesque, point to the Space Grotesque file path, change the variable to font-space-grotesque. Make sure it's the double dash at the start. I think we'll only need from 300 up to 700 in this case. And I'll go down and apply its variable right here by saying space grotesque dot variable. The Inter font will be used almost everywhere, whereas the Space Grotesque will be used just for the logo. So we can keep the Space Grotesque as variable, and I'll set Inter as class name. That way, it'll set it as the default font of the application. Now we can head over to tailwind.config.ts and add the space-grotesque font right here by setting it to var --font-space-grotesque. We can go to our page, duplicate it, and call this one as space grotesque, or rather font space grotesque. And if you go back to your application, you can see the difference in the font. And if you want to learn more about setting up multiple fonts and just optimizing fonts in general, I would highly recommend checking out the Next.js documentation page that further explains how we can set up multiple fonts. But for now, I'll teach you everything you need to know to make it work within this app. So that's it. Now you know how to add new fonts to your application using Next.js's local font functionality, which allows you to simply get them from your own codebase. Great work. Hey, welcome back. Another setup lesson. I know, we've been setting things up for a long time now, but this is the last one. And if we properly set up our codebase and development environment, trust me, the process of actually coding out the logic and the design of our application is going to be so much simpler. In this setup lesson, we'll talk about the assets and the metadata. Let's start with the assets. You see this logo image right here? We need to get it from the Figma design to our code. Same thing for all of these custom icons. You have to select it, you have to go right here and export it as a PNG, SVG, or whatever. See, there is one here, 2, 3, 4, 5, 6, 7. There's the magnifying glass. There's also these icons right here. There's a lot of icons and a lot of images in general. And as a challenge for you, you now need to go through this entire Figma design and download all the assets that you think are needed. Everything from the icons to these badges right here. No need to download these because these will be dynamically generated, as the user tags are also user generated. You'll need to get this trash and edit, and even some of these, like there's no question to show illustrations, as well as the background image for the auth that'll appear right behind it. Also, some icons might need to change colors depending on the mode. So you can now take a couple of minutes, go through the entire design and download all the assets with the proper naming convention. That's super important. When you're downloading these, make sure to give them proper names, because that's going to be super important when we need to use them within our code later on. I'll even leave some important information about how to name those assets below this lesson, so you can practice that. So when you download them, where are you going to place them? Well, you might know that based on what I taught you in the introduction, where I told you what all of the files and folders are for. In this case, the public folder right here is for the assets. So you would need to delete everything that is currently on there and then start moving your assets in there. Once you fully do it, or once you download a couple and you feel like it's enough, you can then get the full public folder from below this lesson and then copy and paste it here. It's going to look something like this. It's going to contain our favicon, some other SVGs, and then all the images like auth dark, auth light, dark illustration, default logo, light illustration, logo.png, and then all the different icons we'll be using. There's quite a lot, as you can see here. So even though you might have started downloading it, might be a good idea to just get this public folder, just so we have the exact same naming for different arrows, avatars, medals, and so on. Once you have them all here, we can test it out. And we'll test it out by using the smallest of them all, which is the favicon. What you have to do is drag and drop the current favicon to the app folder, which is going to replace the old one with the new one. After that, we can focus on the metadata. So if you scroll down, you'll see that Next.js exports a metadata object. Metadata contains information about your site that helps search engines understand its content. It's not something that users usually see, but it's embedded into the website's code. For example, the title tag tells search engines the title of the website, while description provides us a brief description of the site. This helps with SEO by improving visibility. It boosts click-through rate because users know exactly what they're clicking into, and it improves the accessibility. In short, Next.js metadata helps search engines rank and show your site to the right audience. We have the static metadata, or you can even use dynamic ones to make it different for each page. So let's improve our metadata a bit. I'll go ahead and modify the description a bit, saying that Devflow is a community-driven platform for asking and answering programming questions. Get help, share knowledge, and collaborate with other developers from around the world. Explore topics in web development, mobile app development, algorithms, data structures, and more. This is useful for search engine optimization. We can also go a step further and choose icons, icon, and set that to p.2 images site-logo.svg. Now, if you go back to the browser, changes won't be immediately apparent, but you can see right here that we have a new favicon and the title. And with that, we also have 59 new changes. I think this is the most that we'll have in a single commit, as we have just added all of the necessary assets for the entirety of the project. So let me just enter the message, assets and metadata, commit, and sync. Before we finish with the setup, there's one cool thing that I like to do to clean up my file tree even further. And to do that, we can go into the .vs code, and then right at the bottom, you can say something like this, files.exclude, and you can exclude the .vs code, the .next folder as well, maybe even the node modules, as we don't have to see it that often. We can also exclude this next-env.d.ts. You can see how simple it is. Now, if you save it, you can see that now we have a bit of a cleaner work tree. This is also possible in other editors, but VS Code makes it super simple. And with that, we're completely done with the setup and are ready to dive straight into the app folder and start implementing our app's first functionalities. Now, let's dive into routing. One of Next.js's cool features is its ability to handle routes out of the box. But before we jump into that, let's first understand how routes are created in React. Here's an example of how a route can be created using React Router DOM version 6 in React. We first import all of the necessary packages from React Router DOM, of course, after installing it as a separate package. Then we initialize our app, which is a functional component, wrap everything in a router, routes, and then we create a new route with a path and element for each one of the pages we want to have within our application. And here's an example of a nested dynamic routing for a multi-page website like an e-commerce site. As you can see, things get complicated pretty soon. And this app isn't even that big. Scary, isn't it? Not only do we need to download and handle an external package, but as our application gets bigger, the routing becomes more complicated, making it harder to manage and understand. Now let's explore what Next.js brings to the table when it comes to routing. Next.js aims to simplify the process by using a file-based routing system. And what does that mean? Well, folders are used to define routes, and files are used to create UI for that route segment. For instance, to convert the previous React.js example into Next.js, we only need to create two folders named About and Contact, and then we'll create a special file associated with that route segment inside each folder, a file called page, with an extension of JS, JSX, or TSX. Now let's understand it while we code. Quickly create a new folder, and we can call it routing, and then drag and drop it to your empty Visual Studio Code. While in there, go to View and then Terminal to open up a built-in integrated terminal. And we can quickly spin up our Next.js application by running npx create-next-app, add latest, and then /, and press enter. It's going to ask us a couple of questions. For now, let's say yes for TypeScript, no for ESLint, yes for Tailwind, no for source, yes for router, no for alias, and this is it. I just press enter on all of them. This is the default installation process. This is going to install all the necessary packages we need and no additional package for routing. That's important. Once the packages get installed, you'll notice a basic file and folder structure. Now let's clean it up a bit. Go to the globals.css file, delete everything that's there, and simply add a couple of properties. Main, padding to rem, display flex, justify content center, align item center, and flex direction column. Then you can go within your page.tsx and remove everything, including this main tag. This is all just basic boilerplate from Next.js. And the only thing we want to have in there is going to be a main tag that's going to have an h1 of home. Now let's simply save this file and run it by running npm run dev to ensure that application is working correctly.
And there we go. You can see home right here. Now let's create a simple navigation bar component to move between different pages. Create a new components folder inside of the root of the application. And inside, create two files. One is going to be called navbar.jsx, and the second one is going to be called navbar.module.css. Within our navbar folder, I'm going to paste the code that you can also find below this lecture. It's going to be a simple navbar component. In case you want to follow along, feel free to pause this video and type it out by hand. We first have to import some things right here, but you can also just listen to me and understand the concepts that way. Or you can copy this and then replicate the entire application and then go through it and change some things around to fully understand what's happening. But still, I'm going to explain every single little detail. First, we want to import the link component from next link. And we also import some styles so that our application looks better while we showcase it. Then we create an HTML5 semantic tag called header and nav. And most importantly, we create an unordered list of links where we have each individual link pointing to a different path in our application. And below, you'll also be able to find the styles. We're simply styling a navigation bar here. Nothing too complex. But now, to ensure that this navbar is appearing on all route pages, we have two options. The first option is to import the navbar in each route page. For now, we only have one, but imagine if our app grows, it's going to be hard to import the navbar into every single page. And keep in mind, that's how we have been doing it in React so far. And the second option is to import the navbar component in the parent component of these routes, such as layout.tsx. Importing it into the layout component will consistently display it across all routes. So going to the page, importing it right here at the top of the page, and then displaying it as a self-closing component right here within the main is the wrong choice. We don't want to do that. Because then once we create a new page, we would have to replicate this entire thing. Not ideal. So the right method is to go within the layout.tsx, import the navbar right here, and then call it right here within our body. This is now going to appear in all of our pages. And by now, if you have followed all the steps properly, you should see this inside your browser. Next.js, and then these three links on the right side. And now it is routing time. To create a route for the About page using the file-based routing system, we need to create an About folder inside of the app directory. It is important to ensure that the file name inside this folder is lowercase, as the name of this folder will be exactly the same as the route. So let's create an About section. After creating the folder with the name About, create the special UI file called page.js or JSX, or in this case we're using TypeScript, so TSX is fine as well. And there we'll simply need to export default function page would return main h1, but this time it's going to say About. Well, that's it. Go to your browser and click the About link in the navbar. You will notice that the URL changes and the text displayed switched from home to About. How easy is that? Especially compared to the React.js code we examined at the start. Now go ahead and create a route for contact in the same way. Within the app directory, create a new folder called contact. Within it, create a new page called page.tsx. And once again, export default function, contact. After saving the changes and returning to the browser, if you click contact, you get redirected. And you didn't even have to reload the page. All modifications are immediately visible without the reload, all thanks to Next.js's fast refresh feature. That was all about creating a simple route in Next.js. But what about nested or dynamic routes? What do we have to do? Well, let's explore. Nested routes are as simple as nesting one folder inside of another. For instance, we wish to set up a route named projects/list. To achieve this, we can create two folders. The first one is going to be called projects, and within it, another folder called list. And then inside of the list, we add that page.tsx file containing the interface for the project list. And to simplify the navigation to this page, let's quickly include a link tag within the home page. So inside of our home page, right here, we can add a new link tag, which we can import from next link. It's going to say C projects, and we can give it an href equal to /projects/list. If we save this, and now visit the home page, you'll see C projects. And clicking on this link will take you to the route we created, which is /projects/list. And here you can see it in the URL as well. So simply nest folders within one another and create whatever route you want. Moving forward, we have dynamic routes. Think of it as nested routes, but with a slight difference. Unlike traditional nested routes, where we need to know the exact route name in advance, dynamic routes allow for more flexibility. The route is determined based on changing data in the application, so we don't need to predict it beforehand. For instance, if we need to show various project details, we can design a single details page with a consistent layout for all projects. The only difference is that the data or the content will change for each project. So instead of making separate routes for every project details page, you can use a Next.js's dynamic route. To create a dynamic route, we'll have to wrap the folder's name in square brackets, symbolizing that the content inside the square bracket is a variable. So continuing on our current application, let's add a feature for displaying project details. Imagine we have 3 projects, named Jobit, CarRent, and HipNode. And coincidentally, these are the code names of the projects within the master class. We need 3 routes to showcase these projects. So if we go to our app and then our project list, we can now create 3 different folders: Jobit, CarRent, and we can also do HipNode. And now we would have to create a new page. Although the content is mostly going to be the same, we have to duplicate it inside of each one. And imagine if you had 99 projects, or imagine if you allowed your users to add projects. You could have the unlimited number of them. So this is obviously not the optimal way. And you would even have to keep copy-pasting the similar project details code. This is where dynamic routes come to rescue. So let's delete all of these folders right here, and let me show you what I mean. Within the existing projects folder, create a new folder with a name enclosed in square brackets. So /slug. Slug is simply a name for the ID within the URL of that project. But you can choose any name you want, such as ID or name. In this case, let's use name for simplicity. And within it, we can create a new page.tsx file. For now, let's simply render what we did all the time, which is the project name. To access this route, we will include a link to our hypothetical projects on the projects list page and give them a bit of styling. So I'm going to import the styles, and under my projects, I'm going to show a UL that's going to contain 3 different links. So first, let's indent this properly. And second, let's import the link coming from next link. So pointing to projects Jobit, projects CarRent, and projects HipNode. And just to style it a bit, I can create this new projects.module.css and paste the styles right here. Feel free to pause this video and type them out if you want to, but it's truly not necessary. You can watch me go along. And is there anything else that we need to do? Well, no, that's it. If you go back, you can see 3 of these links appear, and if you click on them, sometimes it takes a bit longer on localhost, but on the deployed website, it is instantaneous, and you will be redirected to projects in that URL, and you'll be able to see project name. Same thing, if we go back and click on CarRent, you see you're on this link pointing to this page. However, something doesn't feel good. While the route for these projects changes correctly, it would be great to see the actual project name displayed on the respective routes page instead of the static project name. So how do we do that? Well, the name part here is our dynamic route segment, and Next.js provides us a way to access what value has been passed through the params prop passed to the page.js. So to utilize the value of this dynamic segment, we need to get it right here through params. And then that's going to include project params.name. And this is going to be equal to whatever you have in the square brackets right here. So if it was an ID, then you would have to say params.id. Whatever name you provide, it will be the same name to access the value through the params object. And now if we go back, you'll see project current. If we go to home one more time and click see projects and go to jobit, you can see project jobit and project hipnode. These are automatically created dynamic routes that we created by simply creating one simple dynamic route folder and file right here. Pretty amazing, isn't it? But that's not even the end of routing in Next.js. Coming next, we have route groups. While working in a file-based system, having many folders right here may not be ideal because you can easily get lost within all of them. But you have to have them because that's how you do routing in Next.js, right? So to address this and offer better control over folder organization without impacting the URL structure, Next.js introduced a feature called route groups. How do we make sense of it? Well, consider the existing structure. We already have 3 folders: about, contact, and projects. Now, if we need to add more functionality like sign in and sign up, we would have to create more folders within the app folder, causing it to grow larger and larger. Well, what if we could limit the number of folders inside of the app folder to a maximum of 1 to 3 and include everything within these folders while maintaining the same route path? In this case, if we try to accomplish a structure that looks like this, where we have app and then auth and then sign in within it, this is going to impact the routing. Why? Because as we learned, each folder name serves as a route. So if we do it in this way, the route name for the sign-in page would be /auth/sign-in. And same thing for the sign up. But we intended something else, right? Our desired route names are simply sign in and sign up. No auth beforehand. But we still want to maintain a proper file organization. We don't want the auth to be included in the URL, but we do want it in our current code structure. To meet this specific requirement, we have route groups. They help organize routes into logical groups like auth, team, dashboard, and more. We can create a route group by enclosing the folder name in parentheses. So let's create 2 different route groups within our application. Primarily, we're going to do one called auth and one called dashboard. But notice how I wrapped it in parentheses. Now within it, we can create those auth pages we're talking about. So we're going to have a sign in, and we're going to also have sign up. And within those, we're going to have page.tsx that's going to say sign in, and we can duplicate this and create a new page.tsx, and this one is going to say sign up. And now these are within the enclosed route group. So here's how the structure appears. Everything gets enclosed within here. Now let's transfer the remaining folders, about, contact, and projects, into our dashboard route group. So we simply drag and drop them within it. Now, once you transfer all the files, a simple structure should look like this. A simple auth folder with a sign in and sign up, and a simple dashboard folder with about, contact, and projects. All set. Now let's put our application to the test. If we go to the home page, everything works. About, same thing. Contact works as well. And then if we navigate to the project list, That works as well, and each project details page works too. How surreal. No code breaks, and everything works flawlessly, as if nothing had happened. The URL, the linking, everything is functioning perfectly, and all on the first try. Moreover, now if we modify a URL to sign in, you can see the sign in appear right here. And same thing for the sign up. It's not under auth sign in and the sign up, it's just sign in or sign up because we used route grouping. That, my friend, is the beauty of Next.js 13. And is that the end? End of routing? Well, of course not. There are two more amazing client-side routing features, parallel routes and intercepting routes. And not to forget, we also have API routes. We will discuss more about these in the advanced routing chapter. Now, I have a task for you. Create a complete routing structure for an e-commerce project using different routes. Here are the expected routes we want to have. Homepage, product listing page, product listing details page, shopping cart page, checkout page, order confirmation page, user account page, login page, registration page, and search results page. Try building it out using the route concepts we just learned. Next, explain how does the Next.js routing differ from React.js routing. What is the purpose of route groups and how can they be created in Next.js? And finally, what is a dynamic route and why should we create dynamic routes in web applications? This was a great lecture. I hope it was truly eye-opening and I hope that you like this file-based routing system as much as I do. At this point, I would highly recommend spinning up a new Next.js application and just playing with it a bit. Try creating folders, files, route, pages, layouts, and just test it all out. See how it works under the hood. You have to test it to be able to fully get it, not just listen to me talk. So do some testing and I'll see you in the next lecture. By now, you surely understand that Next.js is a mix of a bit of server-side and a bit of client-side rendering to get the best out of both worlds. But we have to figure out when to use which of these two provided options. Can we choose what to render in each environment? And if so, how can we do that? Before I answer these questions, let's go back to remind ourselves, what do we mean by client and server? What do these terms actually mean? The client refers to the device you're currently using, such as your smartphone or computer. The device sends requests to the server and displays the interface that we can then interact with. The server is essentially just a computer device, but it is equipped with a strong configuration and remains operational continuously. It is where all the code for our application is stored. So when the client, meaning our device, sends a request, the server performs the necessary computations and sends back the required outcome. In previous versions of Next.js, specifically versions before 13, we faced limitations where server-side rendering was restricted to individual pages. This meant that only the route pages like // about, or / projects, and so on, could be rendered on the server side. This limitation led to challenges such as props drilling and duplication of API calls when passing data to lower level components. I recommend reading the Less Code, Better UX, Fetching Data Faster with Next.js 13 App Router article to gain a deeper understanding of the differences between the pages directory and the app directory in Next.js and how they address these limitations. It provides a truly detailed insight into the topic. And that, my friend, is where the app directory comes into action. It not only introduced many features, but also brought the revolutionary change, component-level server-side rendering. Now, what does that mean? And that means that we now have the ability to choose where we want to render specific components or sections of code. For instance, let's consider a component called navbar.jsx. With this new capability, we can decide whether we want to render it on the server side or the client side, in the user's browser. And that's how we end up with two types of components: client components and server components. Now, what are these? Simply put, both are React components, but the difference lies in where they are rendered. Client-side components are React components that run or are rendered on the user's device, such as a web browser or a mobile app. And server components are React components that run or are rendered on the server, which is the place where our application is deployed. But you might be wondering, why would you want to render such a small component on the server side? Well, think about it. By strategically deciding to render certain components on the server side, we can save users' browsers from doing extra work with JavaScript to show these components. Instead, we get the initial HTML code for these components, which the browser can display immediately. This reduces the size of the JavaScript bundle, making the initial page load faster. And nowadays, every millisecond counts. So, rather than fetching and passing data to components separately, we can fetch the data directly within the component, turning it into a server component. So, if we choose to do server-side rendering, we have many different benefits. The first one is smaller JavaScript bundle size. The size of the JavaScript code that needs to be downloaded by the browser is significantly reduced because we're just returning HTML. Enhanced SEO, search engine optimization. Server-side rendering helps the browsers improve search engine visibility and the indexing of your website's content. Remember? We talked about that a couple of times so far. Faster initial page load for better accessibility and user experience. Users can see the content more quickly, leading to a smoother browsing experience. Efficient utilization of server resources. By fetching data closer to the server, the time required to retrieve the data is reduced, resulting in improved performance. Okay, but let's get back to the big question. When to decide what to render where? A lot of question marks in that one single question. As the name suggests, where to render each component depends on what the component does. If a component needs the user to interact with it, such as clicking buttons, entering information in input fields, triggering events, or using React hooks, then it should be a client component. These interactions rely on capabilities of the user's browser, so they need to be rendered on the client side. On the other hand, if a component doesn't require any user interaction, or involves tasks like fetching data from a server, displaying static content, or performing server-side computations, it can be a server component. These components can be rendered on the server without any specific browser features. So, when deciding which one is it gonna be, just ask yourself, does the component require user interactivity? If the answer is yes, it's a client component. And if the answer is no, it's a server one. So to simplify things, Next.js documentation provides a helpful table that guides you on where to render each component. We're talking about server components if you're fetching data, accessing backend resources directly, keeping sensitive information on the server, or keeping large dependencies on the server. And we're talking about client components if we add interactivity and event listeners, such as onClick or onChange, use state and lifecycle effects, such as useState, useReducer, and useEffect, use browser-only APIs, use custom hooks that depend on state, or use React class components. So, now you know. Impressive! You've just discovered one of the most significant features of the modern era. You now know when to use server and when client components. That was a big question, but you handled it like a champ. If you think about it, it's quite easy at the end of the day. You just gotta ask yourself that question. What is it? Does the component require user interactivity? That's it. Now, let's talk about another groundbreaking aspect of Next.js 13's app directory. And that is that all components are automatically considered server components by default. That's right. Every component is treated as a server component unless specified otherwise. So how do we differentiate it from the client component? Well, it's as simple as writing use client at the top of the component file. It's a really straightforward way to indicate that the component should be treated as a client component. Now, that's enough theory for today. Let's dive into coding. So to get started, if you truly want to follow along, you can cd ... to get out of the previous lecture, and then you can again execute create next app, but this time use the name client-server as the name of your new Next.js app. That's going to generate a new client-server folder that you can then cd into. Now, let's get started by going into the app folder. Then go to page.js file and delete all other content, but just keep the main tag as well as the h2 tag. That's going to say welcome. And also add a console log saying where do I render at the top of your home page. Now, after adding that console log, cd into your folder, install the application by running npm install, and then npm run dev to start it. Let's open up the browser to see if we can get our console log within there. Okay, it looks like that our where do I render is not there. How on earth is that possible? Well, you are correct. As we previously discussed, all of these components will be server components by default. So where do we see the console statements if not in the browser? You know that, right? The terminal. Let's return to our terminal and check if the mentioned console log is present there. And there we go. The log is there. Now, let's try to create two more components for each client and server. Inside of the root of the folder, outside of the app folder, create a new folder called components and create two new files inside it, example client.jsx as well as example server.jsx. Within example client, add the use client directive on top, render a component that has a console log, I'm a client component, and a div with a p tag saying this is an example client component. Also, repeat the procedure for the server component, this time without the use client directive, render a component with a console log, I'm a server component, and a div with a p tag saying this is an example server component. And now within our page.js, first import the example client and render it below the h2. Perfect. We can see it there, and we can also see the console log in the browser. Okay, that's right? We explicitly told Next.js to render example client as a client component. Fair enough. But now go back to your terminal, and in there, what can you see? Well, you can see both I'm a client component and where do I render. Why is that? Well, that's because Next.js performs pre-rendering of certain content before sending it back to the client. So basically two things happen. Server components are guaranteed to be only rendered on the server. On the other hand, client components are primarily rendered on the client side. However, Next.js also pre-renders them on the server to ensure a smooth user experience and improve search engine optimization. Next.js, by default, performs static rendering, which means it pre-renders the necessary content on the server before sending it to the client. And this pre-rendering process includes server and client components that can be pre-rendered without compromising functionality. Now, let's play around with these components a little more. Now, import the example server component into the app page.js. Put it right below your example client. And now, if we visit the browser, along with showing both client-server component text on the website, it'll only show I am client component inside the browser's console, whereas the terminal will show all three console logs. All good. Now for the final play, let's remove the example server from app page.js and add it inside the component example client.js. That means that inside example client that has the use client directive and that says I'm a client component, below this div, we're going to also add the example server component. Hit save and see the results in the terminal and the browser. First, you can see what the terminal shows. As expected, we see all three console logs due to the pre-rendering of Next.js and the server feature. But something doesn't look good in the browser console. Why is the server component log appearing there? Wasn't it supposed to be on the server side only? Well, in Next.js, there is a pattern at play. When we use useClient in a file, all other modules imported into that file, including child server components, are treated as a part of the client module. So consider useClient as a dividing line between the server and client code. Once you set this boundary, everything inside it becomes client code. Understood? If not, there is no need to worry. Just remember, do not include server components inside the client components. And in case you encounter such a scenario, I have a solution. We'll discuss it in detail in its dedicated lecture, where we'll dive into the rendering process of client and server components. Additionally, I'll also share some valuable tips and tricks on creating different types of components depending on real-world examples. But now, before we dive into yet another Next.js feature lecture, let's work on some tasks together to solidify your learning so far. Add the useClient inside of the app.js and see where the console logs are appearing then. And then answer me a couple of questions. I want to know. Please try to give me correct answers. What are the different types of components in Next.js, and explain their difference? Okay, you're saying client and server. Okay, that seems good. What are the benefits of server-side rendering? Please don't forget SEO. We talked about that many times. And the last question is, what are the latest features of the app directory regarding the client-server rendering? Take some time, think about it, and if need be, rewatch this lecture. It's a big one, covering a lot of aspects, and I want you to truly nail down the client/server rendering. Don't forget, if you're wondering if a component is client or server, there's one question you have to ask yourself. And that is, does the component require user interactivity? If it does, it's a client component. If not, it's a server one. Great work on coming to the end of this lecture. And don't forget, to truly learn this topic, you have to go to trial and error. We have to test this out in practice. And thankfully with JSM, that's all that we do. So for now, we're going to proceed with additional features, but sooner or later, we're going to explore this in depth within our code. Thank you for your attention on this longer lecture. Now take a break, and I'll see you in the next one soon. We have previously discussed terms like rendering, runtime, and environment, but what do they truly mean, and how does Next.js fit into the picture? You might be thinking, enough with the theory, show me the code. Well, we can definitely do that. In fact, we have already done some best-in-class Next.js project videos for you to dive right into. You can see some of the videos on the screen right now. However, it's important to note that simply watching these videos and successfully deploying your application might not be enough. When you eventually venture into your own projects, you might stumble because you lack a deep understanding of the why behind your decisions. You'll find yourself struggling with the choice. So always aim to clear your why and sit back to watch yourself perfecting the how. In Next.js, there are different ways of displaying elements on pages, called strategies, and the specific times when they run, called runtime or build time, and the specific places where they work, called environment. So let's dive deeper into the rendering process. It's a process of generating or creating the user interface from the code we write. React 18 and Next.js introduced different strategies to render an application. Believe it or not, we can use multiple strategies within the same application to render the content differently, the God mode feature of Next.js. Although we didn't talk a lot about it, there are two environments where we can render our application code: the client, or the user's browser, and the server, which is the computer where we deploy our code. When it comes to the rendering process on the client, it occurs on the user's browser. However, when we render on the server, it happens on the server before sending the page to the client's browser. When it comes to the interactivity and load time, on the client side, it provides a dynamic and interactive user experience, but on the server, it provides a fully rendered HTML page to the client, resulting in faster initial page load time. When it comes to fetching and SEO, on the client side, we have smoother transitions between pages and real-time data fetching, whereas on the server, we have fully rendered content enhancing search engine rankings and social media sharing previews. When it comes to load and performance, on the client side, we have reduced server load and potentially lower hosting costs as the client's browser is responsible for handling the rendering. But if we render on server, then our website is going to perform well on any slower device as rendering is done on the server side. When it comes to consistent rendering, on the client side, compatibility and performance depend on the user's device configuration, whereas on the server side, we will see consistent rendering across any device, regardless of the configuration, reducing the risk of compatibility issues. And when it comes to security, on the client side, we are exposed to a potential risk of security vulnerabilities such as cross-site scripting, better known as XSS, code injection, as well as data exposure. But if we render on the server side, that reduces the amount of client-side JavaScript code sent to the user's browser, thus enhancing security by limiting potential vulnerabilities. So when should we use which one? Well, if search engine optimization or SEO, security concerns, and user device specifications are not a priority for you, and your focus is primarily on delivering dynamic interactivity to the user, then client-side rendering or CSR with technologies like React can be a suitable choice. A use case where this approach is applicable is in the business-to-business or B2B domain. In such cases, the target audience is specific and known, eliminating the need to prioritize SEO since the product is not intended for a wide public audience. This allows you to prioritize developing interactive features without dedicating significant resources to SEO optimization. And on the other hand, if you're someone who cares about all of these points, well, you know what to choose. Now, let's go a bit deeper into how code gets converted into the websites that we see. Once the compilation process is complete, which involves converting code from a higher level programming language to a lower level representation, such as binary code, our application goes through two crucial phases: build time and runtime. Build time is a series of steps where we prepare our application code for production, involving steps of code compilation, bundling, optimization, and more. In short, build time or compile time is the time period in which we, the developers, are compiling the code. Remember that npm run dev script? It's that command that generated the build of our application containing all the necessary static files, bundling, optimization, dependency resolution, and more. Now, when it comes to the runtime, it refers to the time period when the compiled or deployed application is actively executing and running, involving the dynamic execution of the application's code and the utilization of system resources. In short, runtime is the time period when a user is running our application's piece of code. It's about handling user interaction, such as user input, responding to events, to data processing, such as accessing data and interacting with external services or APIs. Now, there's also this thing called runtime environment. And don't confuse this with the runtime we talked about just before. That was the time period of an application, whereas RTE, or a runtime environment, is a specific environment in which a program or application runs during its execution. It provides a set of libraries, services, or runtime components that support the execution of the program. So, Node.js, what is it? It's a JavaScript runtime environment that allows us, developers, to run JavaScript code outside of the browser. Similarly, Next.js provides two different runtime environments to execute our application's code: the Node.js runtime, which is the default runtime that has access to all Node.js APIs in the ecosystem, as well as the Edge runtime, a lightweight runtime based on the web APIs with support to a limited subset of Node.js APIs. Next.js offers the flexibility of choosing the runtime. You can swiftly switch by changing one word: export const runtime, Edge, or Node.js. It's set to Node.js by default, and you just put this at the top of your file. Isn't this amazing? Just with a simple word change, a whole new ecosystem emerges. It's like a snap of Thanos' finger, and suddenly a completely different world opens up. And at the end, let's talk about rendering strategies, which is the core of this lecture. Depending on everything we discussed so far, such as rendering environments, the time periods, build time, runtime, and more, Next.js provides 3 strategies for rendering on the server: static site generation, incremental static generation, and server-side rendering. So let's discuss each one in detail. Remember the build time. Well, the famous SSG, or static site generation, happens at build time on server. During the build process, the content is generated and converted into HTML, CSS, and JavaScript files. It doesn't require server interaction during runtime. The generated static files can be hosted on a content delivery network, CDN, and then served to the client as is. The result, the rendered content, is cached and reused on subsequent requests, leading to fast content delivery and less server load. This minimal processing results in higher performance. Although SSG handles dynamic data during the build process, it requires a rebuild if you update anything, as it happens during the build time. An example use case would be any documentation or blog and news websites. All the articles or content are static 90% of the time. It doesn't need any processing. Once built, we ship it as is. Whenever we want to update the content, we can simply rebuild it. But that's still a limitation, right? Because even though a documentation or a blog site is static, from time to time we want to change it. So, to address this limitation, Next.js introduced incremental static generation. It allows us to update these static pages after we build them without needing to rebuild the entire site. The on-demand generation of ISR allows us to generate a specific page on demand or in response to a user's request, meaning a certain part of the websites or pages will be rendered at build time while other is generated only when needed, at runtime. This reduces the build time and improves the overall performance of the website by updating only requested pages for regeneration. With this hybrid strategy, we now have the flexibility to manage content updates. We can cache the static content as well as revalidate them if needed. An example use case would be where we use SSG, what we discussed before, which is static, for article details page, and then ISG for showing a list of articles. Because sometimes new articles might appear, we're going to statically render them, but then the list has to be dynamic because from time to time, new articles can appear. And last but not least, we have server-side rendering. Dynamic rendering, in a nutshell. It enables the generation of dynamic content for each request, providing fresh and interactive experiences. But if we have SSG and ISG, why do we need SSR? Well, both approaches offer valuable benefits, but their suitability depends on specific use cases. SSR excels in situations where a website heavily relies on client-side interactivity and requires real-time updates. It is particularly well suited for authentication, real-time collaborative applications such as chat platforms, editing tools, and video streaming services. SSR involves heavy server-side processing, where the server executes the code for every individual request, generates the necessary HTML, and delivers the response along with the required JavaScript code for client-side interactivity. Due to this dynamic nature, caching content responses becomes challenging, resulting in increased server load when compared to SSG or ISG. However, the benefits of real-time interactivity and up-to-date content make SSR a valuable choice for specific application requirements. But hey, we have the freedom to choose any of these rendering techniques for any part of your page code. Yep, you read that right. By default, Next.js uses static site generation. However, we can easily switch to incremental static generation or server-side rendering depending on our requirements for different parts of our application. The flexibility of Next.js allows us to pick the most suitable rendering approach for each page on our website. Okay, but when do we use each method? Well, we have to ask ourselves a couple of questions. First, will this page or content display the same information for each request? If the answer is yes, we use static site generation or SSG. If the answer is no, let's proceed to the next question. Does this page or content require frequent information updates, potentially every second? If the answer is yes, we use SSR or server-side rendering. If the answer is no, we use incremental static generation or ISG. And my friend, that wraps it up. By understanding what it is and when to utilize it, we can make informed decisions that will impress your managers, bosses, or just clients by how quickly their websites load. The how of all of this is following in the next chapter, so keep watching. But before you go, as usual, try to answer these questions. What does rendering mean? Explain different rendering strategies of Next.js. What is build time and runtime? Explain the difference between them in a web application life. What are the benefits of rendering content in a client versus server environment? And imagine you're developing a large-scale e-commerce platform that requires a rendering strategy to handle a high volume of product listings. The platform needs to display product information, pricing, availability, and customer reviews. Additionally, the platform aims to provide a fast and interactive user experience. Considering the complex requirements of the e-commerce platform, discuss the trade-offs and factors you would consider when choosing between static site generation, SSG, and server-side rendering, SSR, as the primary rendering strategy. These are some questions you have to think about, and I would highly recommend pausing this video on each one and maybe even writing your answers somewhere. I would even suggest keeping an active Notion document while you're going through this entire course. Whatever your text editor of choice is, maybe it's a pen and paper. Keep it open while going through the course or book or any kind of materials and write everything you learn down. All Next.js 13 concepts, all gotchas, all tips and tricks, and maybe all obstacles you encountered. That way, you'll be able to create a library of your knowledge, sometimes often called a second brain, and you'll be able to utilize it to increase your productivity and knowledge as a web developer around the topic of Next.js. Great work on coming to the end of this lecture. I know we covered a lot, so if you need to dive a bit deeper into some of these concepts, take your time and do that. Cover both the light and the dark mode. So what do you say that we go ahead and implement the light and dark mode switch right away? So that way we can start testing both modes right from the start of developing our application. To implement dark mode within our application, we'll use the most widely used package for that purpose, Next Themes. Next Themes has about 5,000 stars, which is always important when you're searching for well-maintained packages, that they're popular and actually used in production. In this case, as they say, it'll give you perfect Next.js dark mode in 2 lines of code, and it supports system preferences or any other theme with no flashing. If you go to their example, you can see that we have system, dark, and this, oh no, light. So let's implement this so that we no longer have to stare at this light screen. First things first, I'll run npm install next-themes. If you try installing it, it just won't work. And sometimes when you're following along some projects and an error happens, you can be discouraged. I totally get that. But in this course, I want to actually teach you how we would go about fixing it. This happens because there's conflicts in the version of React we're using with the version of Next Themes. Basically, a version mismatch. To fix this,
what I would usually do is run force or legacy peer deps, which is a better approach. But in this case, I wouldn't recommend this approach. Let me tell you why. Sooner or later, the next themes package, which right now supports only React 16, 17, and 18, will get updated to support the latest version of React. So instead of just downgrading our React to a lower version, which would cause another set of problems, we can tell next themes that we want to use the React version that we have right now. To do that, we can head over to our package.json, scroll down below the dev dependencies, and add a new option, which is going to be called Package Manager. And here we can say npm version 10.7.0. After that, you can give it overrides. And under overrides, you can say React and say that we want to use the version of React that we're currently using. And you can do that by saying $React. And I'll repeat the same thing for React-DOM and the React-DOM here. So this way, all of our packages will follow these versions of React. Now, after saving the package.json, try to install next themes again by running npm install next themes. And immediately it got installed. After installing, we'll set a theme provider that'll wrap the whole application and allow us to access the next theme specific properties like mode across any part of our application. Specifically, it's a global context API. So let's create a new folder called context in the root of our application outside of the app folder, call it context, and within it, create a new file called theme.tsx. Within here, you can run rafce to quickly create a functional component. But in this case, this component will be a provider. So let's rename theme to theme provider. And every provider's job is to basically wrap the component and then return whatever is passed into them through children. And we can also pass all of the other props that we get. In this case, we have to define the types for this component. So let's say type will be theme provider props coming from next themes. You can see that the next theme package was nice enough to provide us with all of the TypeScript interfaces for using their package. Many new packages nowadays will do that, just so you don't have to write the types yourself. Then, right within it, you can wrap everything in a next themes provider, like this, give it access to all the props that will pass into it, and then within it, just render the children. Basically, what you're doing is nothing. You're saying, I will wrap this entire thing with the provider and allow me to access some of the props, which will allow me to check whether we're looking at the light or dark mode. Now, where's this next themes provider coming from? We can import it, theme provider, as next theme provider coming from next themes, like this. Finally, since we're using props, children, and some other client-side functionalities here, we'll have to turn this into a use client directive. Finally, we actually want to put it to use. So let's head over to our app layout.tsx, where we wrap everything, because whatever you wrap here, it'll be present across the entire application and all the files, which is exactly what we want to do in this case. And here we can wrap the children with the theme provider we just created, coming from @/context next themes, like this. And to it, we need to pass a couple of props. The first one is attribute is equal to class. Now, how can you know what this means? Well, first of all, you can hover over it and then see that this is an HTML attribute modified based on the active theme. It accepts class and then data, meaning any data attribute, like data mode, data color, and so on. For more info though, you can visit the theme provider GitHub page and see what each one of these properties does. The default theme system simply sets the default theme name. The attribute data theme modifies the attributes based on the active theme. Disable transition on change optional disables all CSS transitions when switching themes. In this case, we'll also have to provide it a default theme, which I'll set to system. So it'll automatically recognize our system settings. We can say enable system as well. And finally, disable transition on change. If you go back to your browser and reload, you'll see that we have one error. I'll explain how to fix it soon. But first, notice that my specific website changed to dark mode because of my system preferences. On your Windows, Linux, or macOS device, if you have selected dark as the system preference, then the website will be dark. Otherwise, it'll be light. But let's quickly see what this error is about. It is a hydration error. It's happening because the next theme tries to update elements after they're pre-rendered on the server and sent to the browser for hydration. Basically, the HTML created on the server is sent to the browser. But as soon as it is loaded in the browser, the next theme updates elements, resulting in a different HTML skeleton. This is what a hydration mismatch is. To fix this issue, which is really not an issue, next theme recommends suppressing hydration warnings. And don't worry, because suppressing hydration warnings will not suppress hydration warnings that you may later cause in your app. It will only suppress hydration warnings at one level deep, so we're good. Only this one coming from next theme. So going back to your code where you have the HTML, you can say suppress hydration warning, and I'll save it. Now, if you go back and reload, we have a nice dark mode or light mode, whatever you prefer. I'll be able to manually set it. For that, we'll have to add a theme toggle. But before we go ahead and add it, we'll first need to do a couple of other things, like add a navigation bar at the top, and then the toggle will be there. And second, to implement this toggle, we'll need a dropdown. There are many ways of creating a dropdown, be that creating it from scratch or using it from some styling framework. In this course, we'll be using ShadCN, a component library containing beautifully designed components that you can copy and paste into your apps. What sets ShadCN apart from other styling frameworks like Material UI is that you get only what you want. With ShadCN, you install or have the code for things you want, nothing else. Like, let's say you want to have a dropdown. You search for dropdown menu right here, and you'll see the code only for that component. Nothing else. No code for sidebar, alert, or accordion, card drawer. You only get what you need. This is very unlike Material UI or others, with which even if you want just a couple of components, you need to get the rest of the components on top of it, even though you might end up not using it in your app. So let's go ahead and install ShadCN so we can start adding its components. First things first, we'll have to run npx shadcn add latest init. So back in the code, I'll open up the terminal. That's the second one, as you can see here. The current one already has the code running, and I'll run npx shadcn add latest init. It's going to ask us whether we want to install the ShadCN CLI, so press Y for yes. And now we'll have to answer a couple of questions. It's going to ask you which style you prefer. In this case, I'll say New York. Which color you prefer? I'll go for slate. Would you like to use CSS variables for theming? I'll go with no. And that's it. It'll update your Tailwind config and the globals.css. Success! The project is initialized. After successful installation, ShadCN will create a few files. The components.json file, which handles the configuration part of ShadCN, where it tells it which config you're using and whether to use CSS variables or not. Every time you add a new component through ShadCN, it'll first check this file, and depending on the configuration, it'll create component code. Next, there's also tailwind.config.ts, which ShadCN modified to include things like border radiuses, and, well, that's more or less it. It also included Tailwind CSS Animate, which is a special plugin for Tailwind CSS. Finally, it also created a new lib.utils file, where it has a helper to manage different class names based on condition without using the template strings. I'll explain it later. But for now, let me show you how we can start using ShadCN's first component, which we'll need. That's going to be a drop-down menu. We can install it by running npx shadcn add latest add drop-down menu. So just go to your free terminal, paste that command, and press enter. It'll check the registry, install the dependencies, and in a matter of seconds, it'll create a new file called dropdown menu tsx. It created it within the components and then UI folder. And you can see the full code for our drop-down menu. There's a lot of code, but don't worry about it because you don't actually have to make any changes right here. You can just use it. Like if you go to the app, you can then see how the usage would work. For example, you have to get all of these imports, paste them at the top, and then you have to copy the usage, paste it below the H1, save it, And as soon as you do that, you can see open, and there it is. You actually have a fully functional dropdown, which is fully tested, works perfectly on light and dark mode, different screen sizes, and so on. It is super simple to add new components. For now, I'll delete this, just so we can start focusing on creating the navbar, and then we'll use this dropdown later on exactly where it should be used. So let's do that next. Before we dive into creating the navigation bar, I want to explain to you the design a bit and how there's going to be different types of navigation in our app. First of all, we'll have our navigation bar, which will contain the logo, the global search for the entire application, the theme switcher, and finally the auth icon. On the left side, we have our sidebar, which we'll use as the primary navigation in our app. And finally, there's the right sidebar, which appears on larger devices and also shows some popular tags. The best developer isn't someone who knows how to code, but the ones who knows how to organize and architect their code in a way that anyone going through it will have a general idea of what's happening. And the first and hardest step in becoming a better developer is understanding how to write better names. Good names for variables, functions, and even files and folders. In our case, from the design, we can notice that there are 3 navigation-related parts. So, to manage these properly, we can create a new folder called Navigation. We'll create it right within our Components folder, Navigation, and within it, we can create a new folder called Navbar. This is a folder and not a file because we'll have to separately handle the mobile navigation and theming inside it, as well as the desktop navigation. This way, we'll keep them close, but still separated from each other. So within it, let's create a new index.tsx file. Now, use rafce to quickly spin up our navbar component, rename it to navbar, and turn this div into an HTML5 semantic nav tag, and just make it say navbar for now. Next, we want to import this navbar in our layout.tsx because we want it to show everywhere in our application. So let's head below the theme provider, right above the children, and here you can render the self-closing navbar component coming from navigation navbar. If you do that and go back to your application, you'll see the navbar now appears right at the top. This might be a good idea to put our editor side by side by our browser, just so we can see what's happening. There we go. We still have enough space for our code. Now let's go back to our navbar and let's start implementing it. I'll start by providing a class name to this nav element, and I'll give it flex-between. You'll notice that flex-between is not a Tailwind CSS property. If I hover over it, we cannot see what is it about. There will be many classes in which we have to use flex justify between item center, or for example, flex justify center item center. This idea comes from having to do this multiple times when building all the different applications I've built. So to avoid writing these long class names, we have to reuse them whenever they'll be used. For that reason, we have created this flex between utility in globals.css. So if you search for flex between, you can see that it's actually applying 3 different class names: flex, justify between, and item center. So instead of just manually calling all of these 3, every time you have to define this class name, you can just use our predefined flex between class name. Just wanted to get that out of the way. Now let's go ahead and create what is going to soon become our navbar. I'll give it a background -light 900 _ dark 200. I'll give it a property fixed so that it's fixed at the top, as you can see. Z of 50 so it appears above other elements. W full so it spans over the full width. Padding of 6 to give it some more breathing room. On dark devices, shadow -none. And on small devices, padding X of 12. And typically shadow light of 300. So now we have our navbar, which currently hides our text. We can also give it a gap of 5, so we create some space in between the elements. Now, right within it, let's display a Next.js link component coming from next link, and I'll give it an href pointing to / because this is going to be our home logo. So let's give it a class name of flex, items-center, and a gap of 1. And right within it, we can display a next image component that'll have a source equal to /images /site-logo.svg with a width of about 23 and a height of 23 as well, with an alt tag equal to dev flow logo. It is super simple to use it now that we have the full public folder. You can see it appear right here at the top left. Right below this image, let's display a p tag that'll say dev, and then within a span, we can also say flow, like this. We can style this p by giving it a class name of h2 bold. You can see immediately how that changes it. Font dash space dash grotesque, text dash dark 100. On dark mode, text dash light 900. And on max small devices, so this is devices lower than 640 pixels, we can simply hide the logo because we don't have enough space for it. We can also style the span by giving it a class name of text dash primary dash 500. You see how simple it is to use different colors now. And if I expand this a bit to go below 640 pixels, you can see the DevFlow logo appear, but on smaller devices, we'll need screen space for the sidebar, for the buttons to open up the sidebar, the auth icon, and the search. Finally, let's go below this link and let's render a p tag within which we'll have the global search. This will be implemented later on. And right below it, we'll implement a div with a class name equal to flex-between and a gap of 5. Within it, we can render our theme picker. So this is it. This is our mobile navigation. And at the same time, it works perfectly on desktop devices too. This was pretty simple, right? Great job. Now, let's finally create our theme toggle. We can do that by creating a new component in Components Navigation Navbar, and let's call it theme.tsx. Run rafce, import it right here. That's going to be a self-closing theme component coming from /theme, and then you can start implementing it. For creating this entire theme picker, we'll be referring to Shadcn's documentation, because I want to teach you not just how to follow along with me, but also how to read documentation and implement things that it tells you to do. You'll notice that a lot of things you'll be able to reuse from the docs, but some things you'll have to change to make them accommodate your specific application. In this case, we'll be referring to docs Next.js dark mode. So if you search for dark mode and click Next.js, you'll be redirected to this documentation page. We have already done step 1, 2, 3, but now we have to focus on step 4, which is placing a mode toggle on your site to toggle between the light and the dark mode. So let's just copy this part right here and paste it right here in our theme. You'll immediately notice that this breaks our application, but let's fix it step by step. First, let's define this as const theme, as we have initially defined it, is equal to a functional component that we can then export to default at the bottom. So export default theme. Next, we need to install a button component. So let's go to our terminal, and you know the drill. npx shadcn add latest add button. It'll immediately install it, and you can see that it works. It successfully changes the theme. You can now change the theme in just a single button click, from light to dark to system. And the changes you apply here will automatically be reflected throughout all of our other pages and components. How cool is that? Do you need to understand how this code works? Sure, and it's fairly straightforward. We use the use theme from Next Themes, and then we use a Shadcn dropdown that basically changes that setting based on whatever we choose. We then import it into our navigation bar, and just like that, the changes are reflected in our layout, and with the layout, they're reflected in all the other pages because we're wrapping them with the theme provider. And with that, you have successfully implemented the navigation bar, as well as the next themes to modify the themes, and then you learn how to install Shadcn components, and specifically, we installed the button component and the dropdown component to make our theme settings work. Great job. I was about to say that this is starting to look like the finished application, but we're not at that point yet. We just have the navbar. But I think you can already start seeing how all of these different pieces are coming together. we have the layout, which controls all the pages. We have the home page here, the components folder, the UI that contains the chassis and specific components, and then our components right here. Since we made a couple of changes for this entire module, now might be a good situation to push them. In this case, we have set up the light and dark theme. So we can say set up light and dark theme, chassis and navbar. I'll commit it, sync it, and we're good to go. Concepts in web security. Authentication is the process of verifying the user identity, ensuring that the person accessing the website is who they claim to be. And authorization, on the other hand, determines what actions a user is allowed to perform within the system after they've been authenticated. So why do we need authentication in the first place? Well, to protect some sensitive information or to allow some users to perform different actions than other types of users. For example, when they're logged in, we have the info about the user that can create posts, delete their posts, and so on. There are different types of auth, such as session-based, usually stored in a cookie, and here's a workflow of how you can implement it alongside the pros and cons. There's also the token-based or JWT authentication, which also has its own pros and cons. There's OAuth, allowing you to delegate authorization to third-party services, such as Google, GitHub, and so on. And there's a basic auth with username and password. I've also decided to include many resources on authentication and authorization so you can learn a bit more about it. This was just a quick introduction telling you a bit more about what auth is before we go ahead and implement it. So go ahead and read it on your own before you proceed to the next lesson. Mechanisms. There are many different ways to authenticate, so it's important to know how to handle user sessions properly and how to handle the data both on the user's device and the server. And this is where different state management techniques come into play. Of course, cookies are something you're going to hear about often. They allow you to store data in the user's browser sent by the server, commonly used for session management, tracking user preferences, and personalizing user experiences. The client sends cookies with every request to the same server, allowing the server to identify the user and maintain state across requests. Local storage is a different web storage mechanism that allows data to be stored in the user's web browser. Provides a very simple key value storage. You can think of it like a basic JavaScript object stored in your user's browser, where users can also define their preferences, cache data, and store application state. It has a larger capacity than a cookie, which makes it useful for caching different static assets and even be used as offline data storage in PWAs. But it's not super secure. There's also session storage, which is similar to local storage, but it's cleared when the user session ends, when the browser is closed. It is commonly used for storing temporary data that should not persist across sessions, which makes it particularly useful to improve security by ensuring that sensitive data is not stored beyond user session. So how are we going to store sessions for authorization? Well, there's a few different ways. First of all, there is a session token, which is a unique identifier used to authenticate a user session. It's typically generated during the authentication process, and it is used to associate a user with their session data on the server. It is a common practice to store session tokens on the client side and send them with each request to authenticate the user. Keep in mind that session tokens are not associated with session-based authentication only. They can also be used with token-based authentication in form of a bearer tokens like JSON Web Tokens or JWTs. And now each one of these, like cookies, authorization headers, local storage, session storage, have their own pros and cons. So make sure to read the text below, as well as some additional documents, which I decided to provide right below. After that, you can move to the next lesson. Now we can create the routes for our two authentication pages. We can do that by creating two new folders in the app folder. First one will be called sign-in, and the second one will be called sign-up. Within both of these, we'll create a new page.tsx, within which I'll run RAFCE, and I'll rename it to sign in. I'll repeat the same thing for sign up by creating a new page.tsx, running RAFCE, and renaming it to sign up. There we go. So now we have two new routes. There are two things happening now. even if you head over to /sign in, you won't be able to see the route name because it's going below the navbar. And the second thing is that we don't even want to see a navbar on the authentication pages. And how do I know that? Because it's shown in the design. If you head over all the way to the right side of the design, you'll see our authentication pages, specifically these two, the create your account and the sign in. What a great yet simple design. But as you can see, even though all the other pages have the navbar, our auth pages are completely empty. They don't have it. So what do you think? How can we make sure that the navbar shows in all of the other pages besides the auth pages? We can do it by using the concept known as route groups. Route groups allow you to nest additional folders without mapping them to URL paths. And what they allow you to do is to organize your routes into more groups based on section, intent, or theme. And more importantly, they enable you to nest different layouts, allowing you to have a completely different layout for a different route group. The way in which you create them is by simply wrapping a folder in parentheses. So let's give it a shot by creating a new folder in the app folder, and I'll name it parentheses auth. Now I'll move both the sign in route and the sign up route into the auth folder. Now I'll create a second route group by creating a new folder, and I'll call it root, the root of our application. And in there, I'll put our existing page.tsx. Now, as I've just told you, each route groups allows us to have its own layout. So let's create two new layouts. I'll create a new file in the auth folder called layout.tsx, and I'll create another one in the root route group, and I'll call it layout.tsx. It has to be called that way to follow a convention. Now we can move the navbar import from the general layout right here, which contains all of the general information about our app, which we want to show both in the auth routes and the root routes, but we don't want to show the navbar. So let's copy it from here, or rather remove it from here, and then move it over to our root layout by creating a new layout. We can do that by running rafce. We can name this root layout. Every layout has to get children as a prop, and it'll be of a type. Children is a React node, which we can import from React. Then we can return everything in a main element. We can render the navbar right here at the top, and right below it, we can render all the children. Let's copy this entire layout and also put it in the auth layout, but this time we will remove the navbar and just keep the children right here. And in the auth layout, make sure to rename it from root layout to auth layout. If you do that, you'll notice that now we don't have a name mismatch and no error is happening. So just to recap, we now have our app, which contains two different route groups. Outside of those route groups, we have a layout which contains all the general information about our application that we want to show and share with all the route groups, both auth and root. For example, theme provider. We want to make sure that our theme persists on both auth and home pages. Then within the root route, we have a page.tsx, which is going to act as our home page. We can see it by going to localhost 3000, or rather we can't because it's hidden behind the navbar, but we know that it's there. Now, why is the navbar showing here? Because root is referring to the layout within the root where we do in fact render a navbar. But now, if you manually switch over to something like sign-in, you'll see that there is no navbar. There's just the sign-in page. Why is that? Well, because the layout right here doesn't contain the navbar. The only thing it does contain is the sign-in page. I hope this makes sense. Essentially, we just use the route groups to group and organize our code. Another thing I want to mention is that route groups are not reflected in the URL. So to get to the sign-in, you don't have to say /auth/sign-in as you usually would with a normal folder. That's exactly why we use the route groups using the parentheses, so we can just head over to sign in and the page will automatically be there. Pretty cool, right? You just created your auth routes for this application and learned a bit more about implementing route groups in Next.js in practice. Great work. With the question marks. The card box, this form right here, and the social auth part, like the login with GitHub and Google things. But the form itself is a bit different. On the left side, we have just the email and the password, while on the right side, we also add a username. So please, think about this a bit. Remember when I told you that the best developers are not just focusing on coding things out, but rather thinking about the architecture of the system? Well, now is your chance to be that developer. I don't just want to teach you how to become a coding monkey, to develop UI pieces that even AI can do nowadays. I want to teach you how to think and approach problems. So pause this video a bit and think about how you would approach these two different forms using Next.js's best practices. You know that it'll have something to do with both of these individual pages and the layout itself. But how exactly can we make this in the best way possible without duplicating code? Pause the video and think about it. And now I'll show you how we can do it. We can start creating a common reusable layout in the auth layout. Here, we can put things that are shared with both the sign in and sign up pages. First things first, let's give this main a class name equal to flex, min-h-screen, so it takes the full height of the screen, items-center, justify-center, and if you do that, you'll see that now sign in appears right in the middle. But hey, what about this nice looking background that we have right here? We can use it as a background image. So let me show you how we can add it to Tailwind config so that we can easily use it. We can create a new object called background image. And there you can provide the auth-dark URL image, which is going to be a string of URL, opening of the string, /images, /auth-dark.png, close string sign, close parenthesis, close another string sign. And we can duplicate this and we can rename it to auth light. And this will point to images auth light.png. If you save this, you can also go ahead and search for those auth-dark and auth-light images within our public folder. You'll be able to find them there. So now that we have them, let's actually apply a bg auth light and on dark mode, bg auth dark and save it. Immediately you can see a huge background appear, but we can style it a bit by giving it a bg mode of cover, bg center, and bg no repeat. If you do that, it's kind of going to hide for a moment. Let's also give it a padding X of 4, padding Y of 10, and save it. On desktop mode, you can see this nice looking background, but as the screen collapses, you can see it's still visible, but then, yeah, it's still visible here, but there's no question marks as we don't need to see them, as the form will basically take the full mobile width. Right below the main, let's render a section, and this section will have a class name equal to light-border background-light 800 _ dark 200 shadow-light 100 dark 100 min-w-full for full width. And if you save it, you can see that this is going to move the sign in below. Well, that's because we can put the children within it so we can see what we're creating. And now we can see a slight border appear around sign in. Let's also give it a rounded dash 10 pixels for the corners, border, padding X of 4 to give it some breathing room, padding Y of 10, shadow-MD, on small devices, min-W of 520 pixels, and on small devices, padding X of 8. And this now creates a nice looking form-like card. Within it, we can create a div that'll have a class name equal to flex, items-center, justify-between, and a gap of 2. Within it, we can create another div for spacing by giving it a class name equal to space-y-2.5. And within it, we can create an h1 that'll say join devflow with a class name of h2-bold text-dark 100 _ light 900. Below that, we can render a p tag with a class name of paragraph-regular text-dark 500 _ light 400. And here we can say to get your questions answered. There we go. we can go below the div and render a Next.js image that'll have a source of images /site-logo.svg with an alt tag of devflow logo, a width of about 50, a height of about 50, and a class name of object-contain. There we go, that's looking better. And finally, below this div, we have our children. And below the children, we also want to share our social auth. So right here, I can create a p tag that will later on show the social auth. And this children currently says sign in, but actually here we'll put the sign in form. Now let's turn this social auth into its own component by going to the components folder, creating a new folder called forms, and within forms, creating a new file called social auth form.tsx. Run rafce and import it right here. Social auth form. Now we can go right into it and we can quickly get it developed. Let's give this div a class name equal to margin top of 10 to divide it a bit from the title, flex dash wrap, and a gap of 2.5. Within it, we can render a button component coming from chat.cn. And within the button, let's render a Next.js image that'll have a source equal to /icons /github.svg, an alt tag equal to GitHub logo, a width of 20, height of 20, and a class name equal to invert colors, margin right of 2.5, and object-contain. If I save this, you can see a white looking button. Now I'll give this button some class names equal to background -dark 400, light 900. Okay, immediately makes it look better. Let's give it a body medium for the text. Let's give it a text dark 200, light 800, min-h-12 for the height, flex of 1, rounded -2, and padding x of 4 with a padding y of 3.5. There we go. Now it looks like a nice button. And if you hover over the text, you can see that we have some squiggly lines telling us that rounded2 is not a Tailwind CSS class. To fix it, we can head over to Tailwind config under border radius and add it by saying 2, so border radius 2 is going to be 8 pixels. And we can also add 1.5, which is going to be something like 6 pixels. We're using these border radiuses in the design, and they don't depend on any kind of calculation, so they're a bit simpler to use. So now we can say rounded2, and as you can see, it just works. Now below this image, let's create a span element that'll say log in with GitHub. There we go, that's much better. And we can duplicate this entire button right below. And this time, we'll change the logo to google.svg, say Google logo. In this case, we don't need invert colors because Google logo looks good on both light and dark mode. And log in with Google. There we go. Now you can see that we are reusing these class names in both of these buttons. So what we can do is we can extract them by saying const button class is equal to, and we can copy this entire class name. Now, class name can be just equal to a button class variable, which makes our code just a tiny bit cleaner. There we go. That's looking great. And let me also explain what this invert colors class does. If you search for it, I'll select it and press Control or Command Shift F, which is going to automatically trigger the global search for this thing. And you can find it within invert colors. We're using a CSS filter invert property, or specifically a Tailwind invert property, which is going to invert the colors depending on the light or dark mode, which is going to make the icon look good both on light and dark mode. So let's actually check it out. This looks super good on desktop devices. And I'll go back to the homepage by deleting the sign in part in the localhost, change it to light mode, and go back to sign in and take a look at this. Looks super nice both on light and dark mode. And another huge thing that you've done in this lesson is made the layout, which now is going to work for both the sign in as well as the sign up. So if you head over here, check this out. Join DevFlow, log in with GitHub, log in with Google. And then the sign up form is displayed, which means that we can retain the rest of this UI while only changing the form in the middle. But before, let's focus on actually logging into our application by using GitHub. This version of NextAuth, recently renamed to Auth.js, the authentication library you want to use for the web. Completely free and open source. So click Get Started and head over to Installation. We'll be using Next.js with npm. So let's copy the installation command, open up a new terminal window, and run npm install next-auth ath beta. After that, we need to set up our environment by declaring our auth secret. So let's run npx auth secret. It's going to ask us whether we want to install the package. I'll say yes. And it's going to create a new .env.local with our auth secret. You can find it right here. Next, we need to configure it by creating the auth.js config file and object. So we have some specific information for Next.js. Start by creating a new auth.ts file in the root of your application. So that's going to be right here outside of everything, auth.ts. In there, we can copy the code that they give us, import NextAuth from NextAuth, where we export handlers, sign in and sign out functions, as well as auth, which will give us the information about the current session. Next, we have to add the route handlers by creating a new folder under app, API, auth, and then square brackets, NextAuth, route ts. Let's first create it, and then I'll explain why are we using this specific syntax. So we can go over to the app, create a new folder called API, create another folder called auth within it, then create a new folder, square brackets, NextAuth, like this. And then within it, create a new route.ts. Now, why are we using this file naming structure with square brackets, something? Well, as you might know, square brackets denote a dynamic route segment, and represents a catch-all route, which means it will match any number of path segments after it. That's explained a bit more under the catch-all segments of dynamic routing. For example, if you have the app shop slug page, it'll match both shop clothes as well as shop clothes tops, as well as shop clothes tops t-shirts, and so on. In this case, it helps the auth.js package to route things properly. It makes sure that we handle the sign-in, sign-out routes, or any other authentication routes. Now, what do we want to put in this route.ts? Well, we can follow what the docs say. We need to import the handlers, and then we have to export, get, and post route handlers. Finally, we need to create one last file called middleware.ts, that's explained here, where we can copy and paste the code they provide, export auth as middleware from NextAuth. Now, the basis for our auth has been set up, but we have to set up different authentication methods, such as the providers, GitHub and Google. Let me show you how you can do that. Head over to github.com, click your profile icon, and then go to Settings. Scroll to the bottom where you can see Developer Settings. And then don't create a new GitHub app, but create a new OAuth app. You can see I have a couple. You can click New OAuth app and give it a name. I'll use DevFlow, and I'll set up the homepage URL. In this case, it has to be HTTP, not HTTPS, // localhost 3000. And we also need to set up the authorization callback, which is going to start with the same URL, but it's going to point to the route we just created, /API, /auth, /callback, /GitHub. And in this case, we don't really need to enable device flow as it's used to authorize users for headless applications. It's designed for devices that don't have an easy way to input text like smart TVs or IoT devices or gaming consoles. So by enabling this, a user is prompted to scan the QR code and then log in with their different device. You don't really have to enable it, but if you want somebody to view your app on a smart TV, then feel free to turn it on. Now, register your application, and you'll be given your client ID. So let's copy it, go back to our code to the .env.local, and let's paste it right here. This will be our auth _GitHub underscore ID. So you can say equal to, and then we have our string. After that, you can also generate a new client secret. You'll have to authenticate your account to do that, and then you can just copy it. Back in your code, you can say auth underscore GitHub underscore secret and make it equal to the secret that you just copied. And you can see that now we have the general auth secret, we have the auth GitHub ID, and the auth GitHub secret. Now, you don't have to wrap these in string signs, but I usually like to do it just to get syntax highlighting and to make sure that everything in here actually is a string. Now we want to head back over to auth.ts and we can add our first provider, GitHub, coming from next auth providers GitHub. And now that we have the general setup done and ready to go, in the next lesson, I'll teach you how to fully implement GitHub OAuth so you can sign your users into your application. I actually took some time to prepare this flow diagram for you, where I can show you in detail exactly how authentication works. I'll explain it once right now, then we'll build out the exact steps that will allow this to happen, and then we'll revisit it so hopefully you fully understand how everything works, not only in theory, but also in code. So first of all, we have an anonymous user right here that clicks sign in with GitHub. That's a button on a Next.js page. Then we initiate an auth request over to next auth, which then redirects the user to GitHub auth. The GitHub auth then presents a prompt for authorization to the user. User presses yes and authorizes the app. After that, GitHub redirects over to next auth with the auth code. Next auth then exchanges the code for the access token. And finally, GitHub returns the access token back to next auth, which then creates a session. We set the session into a cookie. And finally, we are redirected to the authenticated page, which is the home page in most cases, with the full session, including the user data, such as name, username, and email. Now, let me show you how we can do this in code. First, I'll install a new ShadCN component by running npx shadcn add latest add toast. The toast is a little notification that shows up and gives the user some kind of a notification. Next, we want to create a new file called constants. So let's do it right here in the root of our folder and call it constants. Within constants, create a new file called routes.ts. This is another amazing enterprise level tactic to use in all of your future apps. Basically, you can define a new object called routes that allows you to simplify your routing names. Like if you go to home, you can simply define home right here as the /route. And we can do the same thing for sign in, which is going to point to /sign in. And we can do the same thing with sign up, which points to sign up. After that, we can export default those routes. Now, you might be asking yourself, like, why are we doing this? Why are we declaring a separate object and then basically recalling this variable, which is just a string, nothing else? We could have retyped this string. Well, there are many benefits of doing this. First one is reusability. You can point users to the sign-in route from many different places, many different buttons, and many different pages. Now, what happens if the URL for the sign-in route changes? You would have to go ahead and change that route in every single place. But if you have a centralized place where that route is stored, you can just go here and exchange it here, and immediately this variable change would be reflected everywhere where it's used. But not even that is the primary reason why I like to use it. The primary reason is that if you are redirecting somewhere, let's say that you have a redirect, and then you type, for example, /sign in something. It is very easy to make a typo right here. And if you make a typo, it sometimes is very hard to notice it. But with the variables approach, you can say something like redirect to sign in. And if you mistype it, immediately you're going to get an error message saying that sign in is not defined, but routes.sign in actually is. So this is one quick way to make your code less error prone and more reusable. Again, it'll start making more sense once we use it within the code. Now we can go to the components folder, specifically the social auth form, and we can implement the sign in for GitHub. Let's do it by declaring a new const handle sign in function, which is an async function that accepts the provider we want to sign in with, which can either be GitHub or it can be Google. So we're already letting TypeScript know that. Then we can open up a try and catch block. In the catch, we can console log the error, as well as show a toast. So let me show you how we can trigger a toast. The only thing you need to do is say toast, coming from hooks use toast. To it, you can pass the title, such as sign in failed, and you can pass in a description as well, which is going to be equal to if an error is an instance of error. In that case, we can render the error.message because message exists on the error type. Else, we can show a predefined string of an error occurred during sign in. And finally, we can also give it one more variable or one more prop of variant is equal to error. Or rather, I think Shatsian does destructive. Yes, this definitely is a destructive toast if we cannot sign in successfully. So we want to show it to the user. Why don't we go ahead and throw a new error right here and say not implemented, and let's give it a shot. Of course, we need to call the handle sign in somewhere. So we can call it right here on our button click. We can say on click is equal to a callback function where we call handle sign in. And in this case, we pass GitHub as the provider. We can also duplicate this on click and pass it to the second button, but this time we'll say that the Google is the provider we're trying to sign in with. You'll notice that we immediately get an error, and that's because we're using some on-click functionality, which basically makes this a client component. So now is a good time to add a use client directive at the top to fix this issue. You'll also notice that we have a hydration error. I'll look into fixing that soon, but for the time being, let's try to see this toast in action by heading over to our general layout, and then right below the body, we can place a toaster, self-closing toaster component. As simple as that. Now, if you click login with GitHub, you can see sign in failed, not implemented. Good, at least we know that is working. And I think it makes more sense placing it within the body right here. There we go, this is good. And we can go back to social auth, and we can focus on implementing the try block, meaning how are we actually gonna do the functionality? It is pretty simple. You await sign in function, which is coming from nextauth/react. To it, you provide the provider, and then you have an options object where you have a callback URL, which is going to go to routes.home, and make sure to import that routes from constants routes. And then we can have a redirect set to false. See, if you misspell home here, it points to an issue. But if we were using regular strings and if you misspell it, no issue there, right? So it's always better to use constants which are declared in a separate file. Great. And I think that putting the toaster in the body actually fixed the hydration error. As you can see, it's no longer appearing for me. But if you're seeing a hydration error, and if you try to fix all of the mistakes in your code, then it's possible that it is due to some browser extensions modifying the HTML. So in that case, maybe you can reload. If it's still there, keep testing it, and try disabling your extensions one by one. With that said, now that we have implemented the handle sign-in function, let me actually teach you about the two ways in which we can sign in using GitHub or any other provider, or even through credentials in Next.js. One is within client components, like this one we're within right now. You can notice that in client components, nextauth/react automatically exposes the sign-in function, which you can then use to authenticate right here. Basically, on click, you await and sign in. Another way would be handling it not within a client component, rather on the server. In that case, you would await a different function. Sign in, but not from Next.react, rather from add/auth. And then you would use a React 19 form component that would look something like this. Let me actually paste it here below this button. That allows you to pass a form action where you can specifically declare only this block of code server-side. This would allow you to render the entire form on the server without your browser ever needing to access JavaScript code. Again, that has some of the benefits, but in today's day and age, I still prefer handling forms on the client side, as it allows us for more detailed and more granular error handling, so you can let your users know what they typed in wrongly, how they can fix it, and how they can submit the form. Now, with that in mind, let's actually try to access the session that'll be generated once our user signs in. To do that, we need to wrap our whole application with a session provider in app layout. So right here, I'll go over the body and I'll wrap it in a session provider coming from next auth React, and I'll wrap it right here below the body. Then we have to declare the actual session, which we can do right here by saying const session is equal to await auth, which we call as a function coming from @/auth. Since we're using await, we have to make this function async. So this is going to be an async function root layout. And see how this is a bit complicated since it's using the export default immediately here. Let's actually turn this into a regular arrow function by saying const root layout is equal to an arrow function, which accepts children like this. It is of a type children React node, which we can import right here from the top. And then we end it here. Yep, that's much better. And then we can run export default root layout right at the bottom. Great. And now it's easy to turn it into async. Great. So now that we have this session, we can pass it into the session provider by saying session is equal to session, and it will automatically feed all of the other pages with the session of the currently logged in user. So what can we do? Well, let's try to log in. I'll click login with GitHub, and I'll be redirected to authorize the dev flow. Going back to our illustration, we're now at this point where I clicked sign in with GitHub, I initiated an auth request, and then it redirected me to GitHub OAuth. Then GitHub OAuth prompted me to authorize, which I will gladly do right now. So I'll click authorize, and we got redirected to the homepage. As you can see, many steps here happened in between. Then we authorize the app, GitHub reaches out to NextAuth with the auth code, NextAuth reaches back to GitHub with the exchange code for the access token, and then GitHub OAuth finally returns the access token, creates a session, sets the session cookie, and then redirects us back to the homepage. I hope that makes sense. So the main question is, do we have access to the currently logged in user session back in the homepage? Let's head over to the homepage, and let me turn this into a regular return function by wrapping it in a function block with a return statement. And right here, I'll say const session is equal to await auth coming from @/auth. And I'll try to console.log .session. If we do that, we of course have to turn our home into an async function. And since we don't have the use client directive at the top, I would be expecting for that console log right here in my terminal on the server side. And would you look at that? User with the name of Adrian JS Mastery with an email and the avatar image, as well as the expiration timestamp for that session, are all returned to us within a simple auth session. So now that we're on the homepage, we can now add the functionality to log out. And in this case, I'll actually be using server side to show you how you can handle forms completely on the server side so we can tackle both approaches. I'll create a new form, and within it, I'll render a button coming from components UI button with a type of submit, and it'll say log out. To this form, I'll pass a class name of padding x of 10 and padding top of 100 pixels, so we can just see it below the navbar. Also, to this form, I'll pass an action, which is going to be equal to an async callback function right here, inside of which we can say use server, which will ensure that the code below strictly gets used on the server. And then we can write await sign out, coming not from NextAuth React, but from @/auth because we're using it on the server side. And it also allows you to pass a redirect to property. And let's redirect it to routes coming from constants .sign_in. Perfect. So what do you say that we go ahead and give it a shot? I will console log the session just one more time to see if it works once we get back to this page. I'll click log out. It logged us out. I'll click login with GitHub again. It's not going to ask us to reauthorize because it knows who we are. And would you look at that, we get back the information right here for the second time. Wonderful. You just implemented authentication using OAuth with GitHub. In the next lesson, we can do a very similar thing, but this time with Google. The process of signing up with any kind of an OAuth provider is almost the same for all providers. Here it says GitHub, but you can basically think of it as Google, Facebook, or whatever else it is. So we'll once again follow very similar steps. But this time, instead of heading over to github.com, you'll want to head over to console.cloud.google.com and create a new project. I'll give it a name of DevFlow and choose No Organization and click Create. The project is getting created, so let's give it a second. There we go. Let's click Select Project and open up the navigation menu and go to APIs and Services and OAuth consent screen. Here, you'll need to select External, meaning that it is for outside users coming to our app. Click Create, and then you'll have to enter your application name. I'll go with DevFlow and choose my support email. You can also enter your app logo by finding it within your public folder, but it definitely shouldn't look like this. It has to be a square. So instead of a logo, I could use this dark illustration right here. That's a bit better. For the app domain, you'll have to enter the same thing as on GitHub, HTTP localhost 3000, and you can copy this link and enter it for the privacy policy as well as application terms of service. Next, for the developer contact info, you can enter your own email. I'll enter mine, and then click Save and Continue. Skip the Scopes menu, as well as the Test Users menu, and go back to the dashboard. Go to Credentials, create new credentials, select OAuth Client ID. For application type, we'll be doing a web application, but who knows, we might do some mobile ones soon as well. Let's enter the name, such as Web Client DevFlow. And we need to add authorized JavaScript origins. In this case, that'll be http:// localhost 3000. And we need to add a redirect URI. So that's going to be http:// localhost 3000 /API /auth /callback /Google. Same thing as in with GitHub. And let's click Create. As soon as you do that, you'll be given a client ID and a client secret. So copy them one by one, go back to your app and head over to .env.local. Add them right here by saying auth Google ID is equal to this string, and then copy the client secret and add it as auth Google secret is equal to this string right here. Go back to your auth.ts file and modify the list of providers to now include Google. In our social auth form, we have already made our handle sign-in function dual, which means that it supports both GitHub and Google. And we have our own Google button right here, which logs us in with Google. So what do you say that we give it a shot? I'll click Login with Google. I selected my user account, and now I can sign into DevFlow by clicking Continue. There we go, we are in, and let's take a look at how our session looks now. Oh, it's the same thing. Session, username, email, image, all works in the same way as it did with GitHub. This is absolutely amazing. You have just implemented OAuth using both GitHub and Google. That definitely deserves a celebration. And you know what else it deserves? A commit. We can commit all of the things that we have added so far. So let me think of a fitting commit message. It's going to be set up auth layouts, social auth form, next auth, OAuth with Google and GitHub providers. Commit and sync. Great. Our form is looking great. And not only is it looking great, but it is fully functional. And even though that nowadays most people prefer to just log in with GitHub or Google, we still need to add some form fields for people that want to use their email. For people that don't trust GitHub or Google with their data and just want to use their email. So let's do that next. pair very nicely with React hook form and Zod validation. And as they say, forms are tricky. One of the most common things you'll build in a web app, but also one of the most complex. So here they provide us with a quick guide of how we can create a proper form. First things first, let's install a form component. I'll head over to a second terminal and run npx shatcn add latest add form. After that, we'll have to create a form schema. So actually, let's follow what they're doing step by step. You can also pull up the shatcn form documentation on the side. I'll create a new component within forms and I'll call it authform.tsx. And within there, I'll start pasting the things that I copy from the docs, starting with the step 1. And here they just tell us how we can define a schema for a specific form. So we can go to the next step where we can define the actual form. So let's copy this and override it. Here, they define the schema fully, and then they create a new form. They define the form using the use form, and they create an onSubmit handler for that form. Finally, we need to build our form. So let's copy all of these imports right here at the top and override the existing imports, and then go down and copy the form component itself and paste it right here in a return statement, return form. There we go. And they say done. That's it. You should have something that looks like this. But of course, we'll take it step by step and I'll explain how everything works here. First things first, let's actually install the input component so we can use it. And I just noticed that the form is asking us whether we want to override the button. Sure, let's do it. And let's run npx shatcn add latest add input as well, because we'll surely need it. Now we can import this form within our sign in and sign up pages by heading over to auth sign in and then calling it right here, auth form. Oh, but we need to rename it first in the actual auth form because they called it profile form, but we'll actually say const auth form is equal to, and then we can export default auth form at the bottom. And now going back to the file, we can import auth form from components forms auth form, and then just declare it right here. And we can repeat the same thing for the sign up page. So let's just fix over this return and import the auth form. Now, if we go back to our application, you can say simple form that says username, shatcn, you can submit it, the validation works, it is great. But of course, now I'll actually walk you step by step through what all of these things in this form component mean, how we can optimize them and further improve them, and also how we can make this form reusable for both login and registration. So let's take it step by step. First things first, we have some imports from Zod, which we use for validation. Then we have some more imports from React hook form, which we use to keep track of our form state. Finally, we're importing shatcn components for buttons, forms, and inputs, and then we're defining the form schema. We want to make this reusable and extensible. So for now, we won't be using therefore schema. Rather, we'll create our own validations. So let's head over to our lib folder, which is right here in the root, and let's create a new file called validations.ts. Within it, we can import z from Zod, and then we can export const sign in schema is equal to z.object, and you pass in a shape of that object. So here you can define different fields that we'll have, such as email, and email is going to be a z.string of a .min of 1 character with a custom message of email is required. And we'll also give it a .email with a message of please provide a valid email address. There we go. So now this is how we're defining the values for our form, specifically defining the validation to make sure that our users have to enter the values of a proper type. We can do the same thing for the password by saying password is z.string .min 6 characters with a message saying password must be at least 6 characters long. And we can also do .max of 100 with a message of password cannot exceed 100 characters. Great. So that's the validation for the sign in. Now, just so you don't have to retype all of this for the sign up schema, below this lesson, I'll leave the validations for the sign up schema. You'll notice that it has the same email and password, but this time we also add the username and the name fields. And in the password, we add some extra validation, saying that it must contain at least one uppercase character, at least one lowercase character, at least one number, and at least one special character to make sure that our users are safe. Now let's head over to our sign in page. Within here, we'll want to tell this form, this one specifically, that is going to act as the sign in form. So we can pass a form type prop equal to sign in. And alongside the form type, we'll also pass a schema, which is going to be equal to sign in schema, which we just created. Since we're passing some special props to a client component, we have to turn this page into a client component as well. So let's add a use client directive at the top. Alongside the form type and the schema, we want to further make this component reusable by passing it the default values, which is going to be an object where we have an email of an empty string at the start and a password that's also an empty string. Finally, we want to pass a function that's going to execute or tell us what happens on submit. So it's going to be a callback function that gets the data and simply runs promise.resolve, where it says success to be true and it passes over the data to the request. So what are we even doing here? Well, right now our auth form is completely non-reusable. It is a form that has its own values like a username, its own onSubmit function, and its own fields. It's given the props so that it can act in many different roles, such as sign in or sign up. We'll make it reusable. So let's actually copy these props and head over to sign up, paste them into the auth form, and don't forget to make it a use client component or page. Change the form type to sign up, change the schema to sign up schema, and we'll also have to pass it some additional fields since signups usually have more fields, like name is an empty string and username is an empty string as well. And we can leave the onSubmit the same. But you can still see that both forms are complaining about this form type that we're passing in. That's because right now it doesn't yet know that it should be accepting anything. It's just its own form. So let's actually destructure the values right within it to tell it that it can actually do more than what it does right now. Let's destructure the schema, the default values, the form type, and the onSubmit handler. We can say that these are of a type auth, form, props, and then T as in type right here. So we have to define that because it's an interface. Auth, form, props, T, which extends the field values coming from React hook form, because we want to make sure that this interface extends whatever fields we have. So it's going to have a schema, which is of a type Zod type T. We also have the default values, which are going to be T. So the default values that we pass in, you can think of as T. Then we have an onSubmit, which has the data, which is of a type T, and it returns a promise, which returns a success of a type Boolean. And finally, we're passing the form type, which can be one of two strings, sign in or sign up. There we go. So now we know exactly what our function is accepting. And we also have to say that this auth form extends the field values. So we can say T extends field values. That's going to look like this. I know this is a bit more advanced TypeScript, but this is what you would typically find in Zod validation TypeScript examples, as well as React hook form TypeScript examples. So just bear with me. Now we can define our form by saying const form is equal to use form, z.infer, type of schema. We have a resolver with the schema right here. And then we need to pass the default values by saying default values as default values coming from React hook form to which we pass the t, which are the values that we pass into the actual form. Next, we can remove this existing function, but we can create a new function for submit, which is going to be called const handle submit of a type submit handler that has the values of t, which is equal to an async function, which for now we can leave just empty like this. And we'll have to use this handle submit and pass it here instead of the on submit. Next, let's define the button text, and this will help us to figure out on which form we're on. So we can say const button text, and if form type is triple equal to sign underscore in, then the button will say sign in, else the button will say sign up, like this. So for now, I will just render it right here at the top of the form, button text, and you can see that right now we're in the sign in form. At the same time, if I head over to sign up, then you can see that we're in the sign up form. And we do get one error. It's a hydration error, which we'll fix later. But now the question is, how can we render different fields depending on different forms? Well, for that, we'll use the default values that we're passing to both sign in and sign up forms. We want to map over this object and display a new field for each one of these. Let me show you how we'll do that. You can open up a new dynamic block and say object.keys, and then pass in the default values. This will allow us to get just names of different inputs, like email, username, and so on. Then you want to map over these inputs by saying .map field, and for each field, you want to return what? Well, you want to return a form field. So let's put this form field one line above, so it fits right here. And now you can see 4 different username inputs. But instead of having 4 different username inputs, we can actually use this field to display proper values. So we can give it a key equal to field, so it knows that we're mapping over it. We can give it a name equal to field as path t. And this path is coming from React hook form, basically telling us that it's going to be one of these default values that we have. After that, we are rendering a form item. Right here under form label, we can check if the field.name is triple equal to email. In that case, I'll simply say email address. But in every other case, I'll render the field.name. So now you can see email address, password, name, and username. But I don't like that this is lowercase right here, so we should figure out how to uppercase the first letter. We can do that with a bit of JavaScript magic by saying field.name dot char at, so character at, position of 0, that's the first character, dot to uppercase, and then plus field.name dot slice from 1 onward, which means uppercase the first one and then return all the other ones. Great. Now you can also see that the placeholder value for all of these is just chatcn, and it says this is your public display name for all of them. Let's fix that. We can do it by fixing up this input right here. We can give it a property of required, a type. If it's field.name, and if it's equal to password, then we want to change it over to a password field, so the users cannot see what this user is typing, else we'll make it a text field. Then we want to spread over all of the other field properties and give it a class name. Paragraph dash regular, background dash light dash 900, underscore dark 300, light dash border dash 2, text dash dark 300, underscore light 700, no dash focus, min dash h dash 12, rounded dash 1.5, and border. If we hover over it, you can see that background light 900, dark 300 doesn't exist. That's because I have an extra dash right here. So it's pretty cool how it saved me there. And now we have a bit more customized fields. We can also remove this form description. There we go. That's more like it. Now let's style the rest of the form field or the form item by giving it a class name equal to flex, w-full, flex-call, and a gap of 2.5 between the elements. Oh, it looks like I have double L in the call. There we go, that fixes it. Let's also style the label by giving it a class name of paragraph-medium, text-dark 400, light 700. This is looking great. And let's also style the form itself by giving it a margin top of 10 and space-y-6 to divide it a bit from the top title right here. And take a look at this. We have a beautiful form. We can also further style this button by giving it a disabled property, and we want to make it disabled if form.formState.isSubmitting is currently on. It's pretty cool how you're immediately getting this isSubmitting state just by using React hook form. In this case, we don't need to make it submit, and we can style it by giving it a class name of primary-gradient, that's immediately better, paragraph-medium to make the text a bit larger, min-h-12 for the height, w-full for the width, rounded-2, padding x of 4, padding y of 3, font-inter, and exclamation mark text-light-900. We use exclamation mark when we want to make sure that we override some of the default ShadCN properties on the button. So this is looking great. We can also change the button text based on the isSubmitting state. So if form.formState.isSubmitting, then we also want to check the button text. If button text is triple equal to sign in, then we want to return signing in, ... Else we want to return signing up, ... Else we want to return the button text, which is just going to say sign in or sign up. So as you can see now, it says sign up because we're in the sign up form. And finally, just so we don't have to mess with the URL bar, let's go below the button and let's make a link that will allow us to move between the sign in and the sign up forms. We can do that by first checking the type of the form. So let's say form type is triple equal to sign_in. And if it is, we can return a p tag. Else we can also return a p tag. Currently we are on the sign up. So let's focus on this second part of the ternary where I'm going to say already have an account ? And then we can create an empty space right within it to divide it a bit from the link. And then right after that, we can render a Next.js link component that's going to say sign in, and we can give it an href pointing to routes dot sign underscore in and a class name of paragraph dash semi-bold primary dash text dash gradient. And there we go. Already have an account, sign in. And now I'm going to duplicate this p tag, paste it right here below. And this one will say something different. It'll say don't have an account ? Then we're going to route to sign underscore up. And here we can say sign up. And check this out. We have a beautiful form with a title and then social auth buttons and the entire form in the background, which is coming from the layout. So these things are always static. You can see how quickly it loads. We also have the possibility to move in between those two different forms, but then we have created a reusable auth form component that dynamically renders the fields based on the schema that we pass into it. So on sign up, we have email, password, name, and username. And on sign in, we have the email and the password. And it is looking great both on desktop. We can also go on smaller devices such as tablets. And finally on the phone, it is looking like it's made for the phone basically. Great. So now we can go a bit up, and there's one thing that remains for us to do here, and that is to actually authenticate the user. So I can add a to-do in the handle submit and say authenticate user. We'll do this soon. But for now, I can clean up this unused form schema, which we're not using because now we have a dynamic one, as well as this form description, which we don't need. And I can take my time to explain one more time what is happening here. So everything starts with our auth layout, where we're displaying the shared things among those two pages, like the social auth form, as well as the background image and the main layout with the form. Then we have two different pages, the sign in page and the sign up page, which render a form. But now what we have done in a smart way is we have made this form completely reusable, which allows us to pass the schema, default values, and the form type, which we're passing differently for both of these forms. And based on these dynamic pieces of data, we're now rendering specific fields and inputs on the form to accommodate those differences. So great job on completing the UI part of the form. We might do the authentication for the logic next, or maybe we're going to do it a bit later, just to focus on some other stuff and not just the form. But in any case, I want you to take a bit of a break now. Go for a walk, eat something, drink something, or just stand up from your computer. You've done a phenomenal job so far, and you deserve a break. So I can't wait to see you in the next lesson. Now that we have the UI of the form completed, even though the logic isn't quite there yet, don't worry, we'll add it soon. We have successfully implemented the logic to log in with GitHub or Google. So let's see if that still works. In this case, I'll proceed with GitHub. And would you look at that? We are right in. Now, before we focus on implementing the left sidebar, which will allow you to navigate to all of the different pages in our application, first I want to focus on implementing the mobile navbar. Because right now, if you look at it, it is not that functional. Now, just before we start implementing the left sidebar on desktop devices, first I want to handle the mobile navigation. That would allow us to, again, navigate to all of these different pages or log in or sign up just straight right here at the bottom left. So to start working on it, let's remove this logout button from the home page. There we go. That is better. And now we can create a new component. That's going to be in Components, Navigation, Navbar, and within the navbar, we can create a new file called mobile navigation.tsx. Within it, you can run RAFCE, and you can import this file just at the bottom of our existing navbar. So head over to the index.tsx of the navbar, right below where we have the theme. And there you can render the mobile navbar or the mobile navigation just by importing it like this. And now we can see it right here at the top right. So let's get into it and develop it. For this mobile nav, we'll use a ShatCN sheet, which extends the dialog component to display content that complements the main content of the screen. You have some kind of a button, and then something shows up from the right, left, or from wherever else. So let's go ahead and install it by copying the installation command. That's npx ShatCN add latest, add sheet. Then we can import it right at the top, and we can copy its usage. So let's simply place it right here instead of this div. If you do that and go back, you can now click open, and it'll open up a nice looking sidebar. But let's style it further. To this sheet trigger, I'll give a property as child, and within it, we'll put an image. That's a next image with a source of /icons/hamburger.svg with a width of about 36, height of 36, an alt of menu, and a class name of invert-colors, and on small devices, hidden. If we save it, you can now see this menu icon, which looks great. And now we can modify the sheet content. Let's give it a class name of background-light 900 _ dark 200 and a border of none. And we can also make it open from the left by giving it a side is equal to left. If you do that and click on it, that's much better. Next, we can remove the sheet header, and to the sheet title, I'll give a class name equal to hidden, and it can say something like navigation. Instead of the description, I'll render a link, and this link will have an href equal to /, meaning it'll point to home, with a class name of flex, items-center, and a gap of 1, and it'll render a logo. So we can get an image right here with a source of /images /site-logo.svg, with a width of about 23, height of 23, and an alt tag equal to logo. There we go. And we can also render a p tag. This p tag will be the same as in our primary navigation. So we can copy it from here, where we say dev flow. There we go. I copied it. H2 bold, font space grotesque, text dash dark 100, dark light 900. And in this case, we don't have to hide it on Mac's small devices. We do want to show it. That's the whole idea. Now we can go below the link and we can render another div with a class name of no scroll bar. So we want to hide the scroll bar, make it flex, and give it a height equal to calc 100 VH minus 80 pixels. You'll soon see why. We can give it flex dash col and justify between. We can also give it an overflow Y of auto. So this way we can nicely position our elements, such as a sheet close, which will have an as child property. And within it, it'll have a section that'll have a class name equal to flex, h-full, flex-col, gap of 6, and padding top of 16. Within the section, we can just render a p tag where we can say something like nav links. Yep, this is where the links will go. Right below this sheet close, we can have another div that'll have a class name is equal to flex, flex-col, and a gap of 3. And within it, we can have another sheet close. Now, why are we putting these sheet close everywhere? Well, that's because whenever we click a link that's in between the sheet close tags, it'll actually close the sheet and redirect us to that link. So for example, this one will have an href of routes.sign-in. So let's import routes from constants routes. And within it, we can render a button that'll render a span with a class name of primary dash text dash gradient, and it'll say log in. Now, if we open up the sheet, there we go. We can see it at the bottom left. Let's further style the button by giving it a class name of small dash medium, btn dash secondary, min dash h dash 41 pixels, w dash full for full width, rounded dash lg, padding x of 4, padding y of 3, and shadow dash none. And there is our login button. Now we can repeat this entire sheet close one more time below, and this one will go to the sign up route, but we'll change the styles just a tiny bit. So I'll delete the entirety of the class names and say small dash medium, light dash border dash 2, btn tertiary, text dash dark 400, light 900, min dash h dash 41 pixels, w dash full, rounded dash lg, border, padding x of 4, padding y of 3, and a shadow of none. And it can simply say sign up, but this time it doesn't have to be in a primary text gradient. It can just be a text that says sign up like this. There we go. So now we have two great looking buttons. Now, one thing I want to mention here is that right above our nav links, we have our sheet title. And currently it's completely hidden because we don't really need it. But if I comment it out and reload, you'll notice that we get an error saying dialog content requires a dialog title for the component to be accessible for screen reader users. Interestingly, we're not using any Chatcn dialog components here or anything related to that. So in this case, we'll do just like what I have done at the start, which is we'll just hide it using a CSS class. Now let's render all of these nav links. We can do that by creating a new component called navlinks.tsx in the navbar folder. Navlinks.tsx, where we can run rafce, and we can import that component right here instead of navlinks. It'll be a self-closing component, and it'll actually be reusable. So in this case, we can pass a prop to it called isMobileNav. Sometimes we're going to call it and it won't be mobile, like on the desktop sidebar, But in this case, we can pass the isMobileNavProp, which by default, if you pass it like this, is the same as if you pass it equal to true. So now let's head over to navlinks and let's start implementing it. First things first, we can accept the prop we're passing, isMobileNav. And by default, we'll set it to false, which means that it'll only be true if we explicitly pass it as a prop. Next, we can define the prop types. isMobileNav will be optional and it'll be of a type Boolean. Now we need to define our sidebar links. Something like const sidebar links is equal to an array of different links, where each link will have an image URL for the icon that explains what that link is, like images, icons, home. It'll have a label of home, and it'll have a route, which is going to be equal to, in this case, /. And now we need to repeat this for all of the other routes so we can then map over them. But I don't want to clutter this view right here, this navlinks page. So let's actually move these sidebar links into our constants. I'll head over to constants, but not constants routes. Rather, I'll create a new index.ts file right here in the constants folder. I'll paste the sidebar links and I'll add the export keyword right in front of it. That way, we can use the sidebar links both in the nav links right here on the mobile sidebar as well as on the desktop one. So always do things while keeping in mind the reusability. Now we'll have home, community, collections, find jobs, tags, communities, and ask a question. Just so you don't have to type all of them on your own, right below this lesson, I'll provide you this array so you can just copy it. It'll essentially be like a couple of different elements, each one having an image URL, a route, and a label. We repeat that for community, collections, jobs, tags, and ask a question. Now we can go back to navlinks and we can map over the links that we just created. That's going to look something like this. We return an empty React fragment, and within it, we say sidebar links dot map, where we get each individual link item, and for each one, we open up a new function block. Within this function block, we need to define a new variable to figure out whether the link we're currently on is the active link, so we can give it a different color. And we can say isActive is equal to, and now what will we use to figure out which one is active? Well, we'll use the URL bar, because if we're on /, then the homepage should be active. But if we're on / ask a question, then ask a question link should be active. So how do we figure out on which link we're on? Well, in this case, since we're working with navigation, we'll surely be working with a client component because we have to navigate somewhere. And when you're working with a client component, you can say const path name is equal to use path name coming from next navigation. And now in parentheses, we can check if path name dot includes the item dot route, and if item dot route dot length is greater than 1, meaning if it exists, or if path name is triple equal to item dot route, meaning we're exactly on that route. If that is the case, then we can form how a link component should look like. So we can say const link component is equal to, and then we can return it right here. Each link component will actually be a link coming from next link. It'll have an href equal to item.route, and it'll have a key equal to, let's do item.label, since each one is unique. Within it, we can have an image, and this image will have a source of item.image URL, an alt tag equal to item.label, a width of 20, height of 20, and below it, we can render a p tag that'll render the item.label. If you save this, we still cannot see anything, but that's because we're not returning this link component. So we can say return link component for each one of these links. And there we go. You can see all of these different links right here. Now we can style them further. Let's give each link a class name. And this class name will be different depending on whether it's active or not active. And for that, we can use a utility class coming from Tailwind CSS called CN, coming from libutils. To cn, you pass some kind of a ternary operator, like isActive, and then based on that, you can specify different classes. If we are active, it's going to have a primary gradient. For example, it'll be rounded-lg, and it'll have a text light 900. On the other hand, if it is not active, it'll have a text-dark 300, light 900. There we go. And in any case, it'll be flex. It'll have item center, justify start, gap of 4, BG transparent, and padding of 4 to create some spacing. And now our icons look much better. We can also style the image by giving it a class name equal to, let's give it a property of cn, and we'll give it a class of invert colors if it is not isActive. So if not isActive, invert colors. Finally, we can style the p tag by giving it a class name of cn, and we're gonna check if isActive, then give it a base-bold, else give it a base-medium. We can also check if not is mobile nav, then we can give it a maxLG hidden. So we want to hide the text on tablet devices if it's not mobile nav. I'll soon explain what this does. This makes our application even more responsive. Great. Now what happens if we try to navigate over to community? It breaks. We got a 404. But the URL indeed changed to community. So let's test it out by creating a page that'll soon become the complete community page. How would we do that? Well, you go to app, you go to root, and you create a new folder called community, and within it, you create a new page.tsx where you can run RAFCE. And immediately, you'll be able to see your community page, or rather you will not be able to see anything because the navbar is hiding it. But at least now we don't have a 404. So what do you say that while we're here creating this community route, we also create the routes for all of the other pages within our application, at least the ones that we can come to by clicking links in the sidebar. Let's create another folder called collections. Within collections, let's create a new page.tsx, run RAFCE, and you can rename it to collections. Let's create another one. This one will be find jobs. So find-jobs, create a new page.tsx, run RAFCE, and rename it to find jobs. Let's continue with a profile page. Oh no, but this one will be a bit different. That's because each profile has to be differentiated by a profile ID. So it actually has to be a dynamic route. Would you have caught this if I didn't mention it? Well, let me show you how it works. We can create a new folder called profile, and then we can create a new dynamic route of ID. So that profile's ID, and then we can create a new page.tsx for that profile details page, within which we can now run RAFCE and say profile. Finally, we have ask a question. So let's say ask a question, and within it create a new page.tsx where you can run RAFCE and rename it to ask a question. There we go. So now we have all of the routes and we can freely navigate to them. If you click home, community, collections. Oh no, collections broke. Let's see, why is that? Oh, I actually typed collection right here. So I'll rename this collection folder to collection instead of collections. There we go. Find jobs. That can be just jobs. So let's rename it over to jobs. There we go. Tags. Oh, I think I completely skipped over tags. So let's create another folder for tags and give it a new page.tsx, run RAFCE, and rename it to tags. There we go. That works. We have a profile. And now a profile will not work because by default, when we're navigating from nav links, we always go to just / and then that route. But as I've showed you, profile has to be dynamic. So for that, we'll have to modify our nav links by heading over into it. And then right below the isActive, we'll have to check if item.route is triple equal to / profile. In that case, we can check if a user ID exists. Then we can reset the item.route to be equal to item.route / and then the user ID. So instead of simply going to that route, we go to the route and then the user's ID. In this case, we can define a dummy ID like user ID of 1. Else, if we don't have a user ID and we do go into the profile route, we can just exit out of this function by returning null. So now if you go back and if you click profile, you can see that it actually works and redirects you to profile / 1. Oh, I have this extra character right here. This could cause a nasty bug if I didn't find it. Take a look in the URL bar if you can see it. I know it's very small, but basically it turns this curly brace into some characters to parse it and turn it into a URL. So we don't want that. We just want to head over to profile and then 1. If I fix it and go to profile, now we're good. Profile 1, and finally ask a question, which is just going to be ask question instead of ask a question. So let's fix it. Ask question is clear enough. There we go. If we do that, we have a page. But now, why do I have to manually close the sidebar every time I redirect to a page? I would want it to close manually. Do you remember what I told you about that? How do we close a sheet? Well, we can use a sheet close. So right here where I'm returning the link component, I can say return, and then if is mobile nav, I can return a sheet close coming from UI sheet as child, and I have to give it a key since we're mapping over different elements, item.route, and then we're going to wrap the link component right within it. Else, if it's not mobile nav, we can just return a React fragment or a div, whatever you prefer, with a key equal to item.route and just a link component without wrapping it into a sheet close. Because if we're in a desktop sidebar, nothing happens. We don't have anything to close. But here, we can close it on click, and this is working great. So with that in mind, great job for completing the mobile navbar, which technically is a nav links component that uses a ShadCN sheet. Now we're going to take it up a notch and we'll develop a left side sidebar on desktop devices. This time it'll be much simpler, considering that we have already created a reusable nav links component, which will help us map over all of the links, because links are going to be the same no matter whether you're on your phone or on desktop. So let me push this. I'll say mobile nav and nav links, commit, sync, and let's continue. Welcome to the very first interactive lesson in the course. This lesson builds on what you've learned so far, offering practical application and hands-on experience. Throughout this lesson and other active lessons, you'll encounter tasks, resources, and hints designed to enhance your understanding. Whether you're new to the topic or looking to deepen your knowledge, this lesson is for you. So get ready to learn, practice, and develop your skills. Let's begin our journey into creating the complete left sidebar component. Your task is to create a left sidebar. Okay, I know we haven't done something like that before. However, that's what makes it exciting. The opportunity to think in terms of user interface. See, that's how it works. You break things into very small pieces and try to find an answer for each piece of the puzzle, and then finally you develop it step by step. So take a pause and think in terms of UI. Make sure that it's responsive and looks exactly like it is shown in the main deployed site or the Figma design. P.S. The login and sign up buttons should only appear if the user is not logged in. And here are the examples. To give you a clear picture of how everything should work, here's a link to the live site, the Figma Dark design, and the Figma Light design. The live site is as simple as it seems. It is a complete website with all the functionalities where you can see how the left sidebar looks like and how it behaves on different viewpoints. As you can see here, the text is hidden, but as we expand it, you can see it right here. In the design, you can better explore specific properties,
by diving deeper into the design elements. So you can click through it and then see different elements of text, fill, stroke, colors, and more. You can also turn on the dev mode, and that's going to immediately give you all of the necessary properties for styling and developing. And finally, there's also a design in light mode, so you can compare the two. Additionally, there are some valuable resources to assist you with the task and deepen your understanding of a concept. You'll most likely need to use a Next.js link, the clerk signed out component, Next.js's use path name, clerks use auth, Flexbox guide, and media queries. So be sure to check them out and gain deeper insights into the topic. And finally, don't worry if you get stuck. Here we have a huge hint to guide you in the right direction. The only thing you have to do is hover over it and it's going to appear. I'm not going to do that right now though. Only do this if you get stuck. So don't be discouraged if you haven't cracked it yet. Learning often involves some twists and turns, so keep trying and you'll make progress. You've got this. So if you successfully completed the task, congratulations on completing this interactive lesson. You're on the right path to becoming an expert developer. And if you face some difficulties, that is okay. Learning is a journey, and challenges are opportunities for growth. There are going to be many active lessons throughout the course, and you will get stuck often, and you won't be able to complete many. But that's okay, because if you just try to do it before the lecture where I show you how to do it, your brain and your synapses will make so many more connections, and you'll be able to better learn for the content that's about to follow, even if you didn't do it successfully on your own. So I highly encourage you to go through each and every active lesson, no matter if you consistently get stuck on them. At the end of the day, they're going to make your learning better and significantly increase the value you can get out of this course. So I just wanted to share this with you before your first active lesson, and in the future, you'll be able to reference these great readmes we prepared for you. We put a lot of thought and effort into each one, and they're not a template. Each one includes special tasks, examples, and resources, as well as specific hints. Once again, this is it for the first one. I wish you all the best.
Having created the mobile nav, now we are ready to turn it into a real desktop homepage navigation in form of a left sidebar. Why left? Well, because we will also have the right sidebar later on. So let's focus on the left first. I'll create a new component in the components folder under navigation, and I'll call it left sidebar.tsx. Keep in mind that now we're outside of the navbar folder because this is a sidebar. I'll run rafce and I'll put it within the root layout. Right here where we have the navbar, we can create a div just below it. And then here we can create a left sidebar coming from navigation. Now you cannot see it yet, so let's actually change some styles here. I'll give this main a class name equal to background -light 850 _ dark 100 and relative. This will change it to a nicer background. Let's also give this div a class name equal to flex, and then below the sidebar, let's have a section within which we'll have a div, and within which we can place this children. Now this section will have a class name of flex, min-h-screen, so it takes the full height of the screen, flex-1, flex-call, so the elements appear in a column. There we go, now we have a different color. We can give it a padding x of 6, padding bottom of 6, padding top of 36, and on max MD devices, padding bottom of 14, and on small devices, padding x of 14. I found those values to work well, and you can see that the padding actually pushes now the title of each one of these pages, so we can see on which page we're on. If I go to DevFlow, we can now see Welcome to the World of Next.js. But that's not why we're here, right? We're here to see the sidebar. First, let me just provide a class name to this div, such as mx-auto, so margin left and right auto, w full, and max w of 5xl. So this is a max width that our content can take. You can see that this just pushed the content to the middle, so we have enough space for the sidebar. So let's develop it. Our sidebar will actually be a section. A section within which we'll have a div that'll have a class name equal to flex, flex-1, flex-call, and a gap of 6, within which we can render nav links. Yep, the same component we used in our mobile nav. Let's fix the typo, save it, and take a look at this. We have something that kinda resembles a sidebar. But now let's style it further. In this case, I can actually put the editor to the right side so we can see what we're doing. I'll give it a class name equal to custom-scroll-bar. So this is to hide the ugly default scroll bar. Background-light 900 underscore dark 200. Light-border sticky left-0 top-0. So we can position it to the top. H-screen, so it takes the full height of the screen. Flex, flex-call, justify between. Overflow, Y auto. Border right, so border R. Padding of 6 to create some spacing. Padding top of 36 to account for the navbar. Shadow-light 300. On dark mode, shadow-none. It's not needed. On max SM devices, we'll simply hide it. And on large devices, we'll make it 266 pixels to give it some more space. That's going to extend it a bit. And with that, we have something that already resembles a very nice looking sidebar. And it's actually fully functional as well. But if you compare it to the design, there's also something that we have on the bottom left. We can have a logout button, or we can have some other buttons, such as these ones here, like login, sign up, similar to what we have in the mobile, but we'll make them just a tiny bit different. So I'll go back and I'll go below the div that wraps the nav links and create another div with a class name equal to flex, flex-call, and a gap of 3. Within it, I can basically copy and paste the two buttons that I have in the mobile navigation. So I'll head down and I'll copy those two sheet closes. I'll paste them right here within this div. But in this case, they don't have to be sheet close. So I'll completely remove the sheet close. The link will actually go inside of the button, like this, and same situation here. Make sure to import the button and the link if you haven't. And on this desktop sidebar, we have some more space to show an image. So right above the span, let's render a Next.js image with a source equal to /icons /account.svg with an alt tag of account, width of about 20, height of about 20, and a class name of invert-colors. And we'll also hide it on large devices, so we can say LG hidden. We only want to show this on smaller devices, and likewise, we will hide the text on small devices. So we can say max LG, we will hide the text, because text takes more space than the icon. Also, we have to give this button as child property, because technically it will become a link. Now we can do the same thing for the second button, give it as child, and we can copy and paste this image that we had from above, put it above sign up, and change the icons from account to sign-up. And we can also wrap the sign up in a span that has a class name of maxLG hidden. I'll show you what this does. So if you look at it, now we have login and sign up text alongside all of the other icons or links. And if I start collapsing it, you'll notice that at one point, all the text elements disappear to allow us to have more space for the central content, which is why we're here in the first place. Not to read the navigation, which at this point is taking a large point of the screen, rather to focus on the content itself. So now as we collapse further, you can see it actually disappears And then instead of it, we have this nice mobile sidebar. This is looking great. So not only did we make this mobile and desktop responsive, it's also tablet responsive. That's when we hide these text elements right here. Great job. Considering that creating the mobile navbar was a lot harder since we were developing this reusable navlinks component for the first time, developing this left sidebar for desktop devices was a breeze. Everything works so smoothly and looks exactly like it does on the design. And while we're on the roll with creating navbars and sidebars, what do you say that we develop the right sidebar next? That's this one that shows the hot questions that people have been asking, as well as some popular tags that have the most questions listed. Let's do that next.